Hello guys, my name is Utkarsh Gupta, and today with us we have Bhavya, who is an ICPC World finalist this year. Before that, let Bhavya please introduce yourself.
So, hi everyone. I am Bhavya Jain. I am undergraduate of IIT BHU Computer Science and Engineering. I interned at Microsoft and I'll soon be joining Microsoft Redmond as a full-time employee. Also, I qualified for ICPC World Finals this year.
Alright, so you might have heard of Fibonacci numbers, right?
Yeah.
Fibonacci numbers go like this. F of I equal to F of I minus 1 plus F of I minus 2 for I greater than 1, and F of I is equal to I for 0 and 1. So let's modify it a little bit. So currently, let's say we are saying f of 0 is equal to some random number a. We will give this in the input. And f of 1 is equal to some random number b. We will also give this in input. Alright. Define a series S of I, which is basically summation of first I Fibonacci numbers. So f of 0 plus f of 1 plus f of 2 up till f of I. And let's define another series that is SSI, which is summation of first SI term. S of 1 plus S of 2 plus up till S of I. So for any given input n, so given inputs will be A and B, which are the initial values of Fibonacci numbers, and value n. We have to find the value of SS of n. So is the question clear to you?
Yeah, I guess, yeah. So I'm assuming n is greater than or equal to 0 because that's what Fibonacci is defined for.
Yes, exactly. So n will always be a natural number.
So we know that Fibonacci series may go exponential, so the sum may also go exponential. So
yes,
how do you store that?
Very good. So in case we have bigger values of Fibonacci numbers and similarly S of I or S of I, we are taking mod. So let's define a mod like 10 to the power 9 plus 7. So you have to return the value of S of n mod capital N. Let's say M is our mod.
So a naive approach would be to calculate all the Fibonacci series, then calculate the prefix sum of the Fibonacci series, which will give us S, and then calculate another prefix sum, which will give us S of n.
All right.
So let's say Fibonacci is X, Y. The first two terms are A and B. So A, B.
Let's take some input. I mean, let's say A is equal to 1 and let's say B is equal to 1.
So yeah, the standard Fibonacci series 1, 1, 2, 3, 5, 8, 13. And if we can go on calculating this. Then we will store the prefix sum, which will be 1, 3, 1, 2, 4, and so on, 7. Then we can store another prefix sum, which will be 1, 3, 7, 14. And we will go on doing this till n, and we will find and we also will take mod so that there is no overflow.
Yes,
and that will give us the nth number in the series S of S. SS.
Right, very good. Can we start with the code of that part first?
Okay. So I'm assuming the bounds on A are like n or 10 to the power 5 or something.
I mean, let's start and then later on we will discuss the complexity part. So just assume you have a function in which you are given inputs A, B, and N.
N, A, and B.
Yes. And we have to return n, S of n, modulus n.
So let's make three arrays, vector int f of size n, s of size n, and ss of size n. We know that f of 0 is A, f of 1 is B. Also, we can see that it follows the relation S of I is S of I minus 1 plus f of I, because since it is the prefix sum. Or actually we can store the prefix sum directly. So let's first calculate f. For 2 to n, f of I will be f of I minus 1 plus f of I minus 2 mod. And since these are both less than 10 to the power 9 plus 7, then the sum will at most be 2 into mod minus 2, which will be in the limits of integers. So there won't be any overflow issues.
Right.
Now, S of 0 is f of 0. And since we need to find perfect sum, so let's loop from 1 to n. And we know that S of I is equal to S of I minus 1 plus f of I mod. Because S of I is the sum of first I numbers, and if we know the sum of first I minus 1 numbers, we can just take the ith number and add it to the first I minus 1 numbers to get the sum of first I numbers.
Yes, perfect.
Using a similar argument, we can do SS of 0 is S of 0, and let's try to find SS of I similarly. SS of I plus S of I using the similar argument, and actually we need to find the nth number, so loop till n, and then we should return S of n.
So will it find right?
Yeah.
Okay, very good. What is the time and space complexity of your program?
So we are looping over n thrice. So in the terms of big O, it should be big O of n. And we require arrays of size n as well. So space complexity will also be on.
Correct. So time is order of n and space is order of n, right?
Yeah.
Can we optimize on the time or the space complexity?
Okay. We see that Fibonacci only depends on the previous two numbers, and also the sum only depends on the last number. So we can somehow store the previous 2 or 1 values to eliminate this array. Let's call f0 I1, which will denote the fi minus 1th number initially, and fi2, which is fi minus 2. So initially fi minus 2 should be A, fi1 should be B. So for 2 to n, let's calculate current f. Current f will be the sum of f of 1 plus f of 2. Let's calculate s and f simultaneously, s, ss and f, because we are not storing anything. So s of I is x, ss of I, actually it is for 2. So ss of 1 should be x plus y, because it's x, y, a plus b, sorry, a and b, a plus b. And ss of I should be a plus b, 2a plus b. So current is f1 plus f2. Now let's date f1 and f2 as well. So now fi minus 1 will be current after this operation, and f2 will be f of 1, because this was f2, this was f1, and now this is current. After the next operation, this will become f2 and this will become f1. So f1 is current and f2 is equal to f1. Now let's try to calculate s of I. So s of I should be s of I plus current f, and ss of I should be ss of I plus s of I. And since we need to find nth number, we'll return SSI. So this should return the nth sum, nth term of the series S of S.
Okay. Anything which you feel can go wrong in this?
Okay. So our initial series is A, B, A plus B, 2A plus B. This is our F. And S should be A plus B, 2 into A plus 2 into B, and so on. And then it should be A into A plus B. So I've initialized it correctly. And current will be the sum of Fi minus 1 and Fi minus 2. F of I minus 1, since we are updating it for the next term, it should be current. And F of 2, Fi minus 2 should be F of 1. So we should return S of I. Logically, I don't see an issue.
One small mistake is there, and two small mistakes I can say. Just try and see.
Okay. I minus 2 is A, f of I minus 1 is B, S of I is A plus B 2. Okay, yeah. So yeah, let's just take mod. This should be mod here. And now let's just assume that all the operations we are doing are under this modulo.
Okay.
So all the sum and multiplication are under this modulo, mod 10 raised to 9 plus 7.
One small mistake is still there, I can say. I mean, just try and see.
Okay, defining current F.
And don't worry about the capital and small cases.
Yeah, Google Doc automatically does it. So
yeah, it's okay. It's okay. One logical mistake is there, one small logical mistake. Just try and observe.
Okay. So are the initialized values correct, right? S of I is 2A plus B.
Any hints? Any help?
Yeah.
F1 equal to current F should be above, should be below F2 equal to F1. Reason is, once you have updated current F, you are initializing current F to F1, and that current F is again added to F2. I mean, F2 is also equal to current F now. Because of this, all the three parameters are equal. So we are keeping using a track of previous.
Keep it here. F2 equal to F.
Yes, correct.
F2 equal to F1, yeah.
Very good. One more small thing, please observe.
I think this is correct because this is the sum of previous two values, and initially it is not even initialized anything, so it will be random value.
Current?
So I think the position of this is correct. This is the current value we are finding.
Yes, that is totally correct. One small thing still. Okay, can you explain this code again once, and maybe then we can observe.
So F2 is the Fi minus 2 value, F1 is Fi minus 1 value, Si is sum of the second value. Okay, so we need 0 first value because we are calculating from 2 to n. So this is the second value we are calculating. This should be A plus B, then 2A plus B, this is the initial value. Then this current F is the Fi, and also we are updating Fi minus 2 to Fi minus 1. And Fi minus 1 will be changed to Fi because this is the value which we will use for the next term.
Right, correct.
And then sum of I is the current sum plus the current F.
Correct.
And S of I will be the current sum plus S of I calculated till yet.
One small thing. If you observe, we mentioned in the start that n can be any value between 0 till larger. So we forgot to take care of n equal to 0, I think.
Okay, yeah. So for n equal to 0, for n equal to 0, it will return a wrong answer. If n is 0, we can return A.
Yes, perfect. Now, what is our time complexity and space complexity?
So our time complexity should be On and space complexity should be O1.
Right. Is there any way to reduce time complexity?
So Fibonacci numbers follow a recurrence, and we can find the nth number in O of log n using matrix exponentiation. So if we can find a similar recurrence for S of S, then we can also do it in log n.
Okay. Can you explain how we find nth Fibonacci number in log n? Time.
Okay. So we know that Fibonacci numbers follow the recurrence f of I equal to f of I minus 1 plus f of I minus 2.
Right.
So let's try to represent it in terms of matrices. So this is f of I, this is f of I minus 1.
Right.
And let's try to represent it in terms of matrix with one difference. Okay, let's say this is a 2 cross 2 matrix which we will find now. And we are multiplying it by f of I minus 1 and f of I minus 2. We should place such numbers here so that this relation is followed. So looking at the matrix relation, we can place 1 and 1 here because 1 into f of I minus 1 plus 1 into f of I minus 2 should yield f of I.
Right, correct.
And we can place 1 and 0 here because 1 into f of I minus 1 is f of I minus 1, and we are then multiplying 0. Okay, so let's try to replace I by I minus 1 in the above equation. So what it should yield? F of I minus 1, f of I minus 2, and then the same thing, f of I minus 2, f of I minus 3. So let's replace this equation f of I minus, this is a vector matrix. So this is a matrix of dimension 2 cross 1. Okay, let's replace this column vector here. So we will see that we get a relation. Let's copy this here. This square into, so this should be f of I. When we replace here, we get f of I minus 1 is equal to square of this matrix into f of I minus 2, f of I minus 3. Okay, so we see that this is I minus 2 and this is square. The sum of these numbers is I, and same here. So this is matrix raised to 1 and this is I minus 1. So I minus 1 plus 1, this sum is I. And we can again replace I by I minus 1 and go on doing that. So in general, we will get a relation that the sum is I. So for f of n, let's say replace I by n. So f of n minus 1. Then this matrix raised to a power. Let's find the power afterwards. And we know the initial two values, f of 1 and f of 0.
Yes, correct.
Okay. So what should be the power so that the sum is n? Because we know that the sum is I here. So it should be n here. So we should raise to n minus 1. So this matrix 1, 1, 1, 0 raised to n minus 1 into f of 1, f of 0. This relation should also follow.
Yes, makes sense.
Okay. So all we need to do is find a matrix raised to a power.
Correct.
And we can do it using exponentiation. So let's say we want to find, we know that we can multiply two matrices, square matrices of order n in n cube.
Right.
Okay. So, and this is, since a matrix of 2 cross 2, we would require 8 operations, 2 cube operations. So let's try to find how we can raise a matrix to a power. So we can, so let's say if n is even, so n is even, we can write a raised to, we can write in terms of 2k if n is even. A raised to 2k should be a raised to k square, or a raised to k into a raised to k. Okay. So, and if it is odd, then let's just write it as a into a raised to 2k. So if we do it recursively, so if n is even, then we will find a raised to n by 2, and we will store that value and multiply the value stored by the same. So if we know a raised to k, we can multiply it by a raised to k and return that value. And if n is odd, then we can just multiply a and call a raised to 2k recursively. So we see that in every two operation, we will reduce n by 2. So if n is odd, then we will reduce it by 1. And if it is even, then we will divide it by 2. So if n is even, we will divide it by 2 in one operation. But if n is odd, we will subtract by 1 and then divide it by 2. So in the worst case, we are dividing it by 2 in two operations. So this will require 2 into log n operations to calculate a matrix power, like a matrix raised to a given power.
Can we code this part where you are like finding matrix raised to the power n minus 1?
Sure. So let's assume that A is a global matrix 1, 1, 1, 0, which we want to calculate, and mult AB is a function which returns a matrix C, which is the multiplication of A and B.
Okay.
So matrix is a class which contains the matrix. Matrix power matrix S comma int n. So if n is 0, we know that any matrix raised to 0 returns identity matrix. A raised to 0 equal to I, and identity matrix is 1, 0, 0, 1.
Alright. One question before we start. You mentioned A is a global matrix with 1, 1 and 1, 0, right?
Yeah.
So what is this S matrix?
So this we will pass it as a function. So we will
Okay.
pass matrix a comma n.
We can just say it's a matrix.
Yeah.
Okay.
So we will return I. I is again, let's say, global matrix 1001.
Okay.
And if n is odd, n and 1, we can return mult. So we will multiply a by power a. Actually, we don't need s, I guess, because if we are multiplying it, so mult a raised to n minus 1, power n minus 1. And if it is even, then calculate mult n by 2. So let's say it is a matrix B. Return mult B comma B.
What is this mult function? It's a mult is.
It returns the multiplication of two matrices.
Okay, but here we are not passing to matrix.
Oh, so sorry. This is power. So we will find a raised to n by 2 and then multiply it.
All right. Can we see a simple diagram like using, let's say, n equal to 6?
Okay, n equal to 6. So we need to calculate a raised to 6. So we will first call, since we see 6 is even, we will call power a cube, power 3. So to calculate a cube, we see that it is odd. So we will calculate a square. Right? Again, it is even. So we will call a raised to 1. Again, this is odd. So we will calculate a raised to 0, which and we reach the base case, which is 0. So we'll return iota, identity matrix, and then we'll go up and above. So we'll multiply a by a raised to 0, and we will get a. Then we will multiply a by a, and we'll get a square. Then we will multiply a square by a, and we will get a cube. Then we will square a cube, and we will get a raised to 6. We will call this function mult BB.
Correct. And as you explained, time lecture will be order of log n, right?
Order of log n. Yeah.
Okay. So using this, like as you explained, based on the matrices, we will be able to find f of n, like n Fibonacci term. Can we find s of n using the same series?
So, like if we can find a similar recurrence for s of n, then we can find it. So let's say we know this recurrence f of I equal to f of I minus 1 plus f of I minus 2, and s of I is f of I minus 1 plus f of I. So we want a recurrence in s. Let's try to express f in terms of s and then replace here. So we know that f of I should be s of I minus s of I minus 1, right? So let's replace f of I here in this recurrence. So f of I is s of I minus s of I minus 1, which should be equal to f of I minus 1, and f of I minus 1 is equal to s of I minus 1 minus s of I minus 2. Again, f of I minus 2 should be equal to s of I minus 2 minus s of I minus 3. And let's try to recollect terms. So s of I should be 2 into s of I minus 1. And this will get cancelled, and minus s into s of I minus 3.
Yes.
So we found a relation for s. But we also need to find a relation for ss. Also, s of s, we know that satisfies this relation. S of I is equal to ss of I minus 1 plus s of I. So we can do similar thing like we did here and produce a series. So let's say call it 1, and s of I is equal to ssi minus ssi minus 1. So replace this in the equation 1.
This is equation 1, right? Just so that you don't have any.
Yeah. So ss of I minus ss of I minus 1 this should be equal to 2 into SS of I minus 1, and SS of I minus 1 is equal to SS of I minus 1 minus SS of I minus 2. And then we will subtract it by S of I minus 3. S of I minus 3 should be equal to SS of I minus 3 minus SS of I minus 4. So let's try to collect terms to one side, and we will see that SS of I will be, let's try to find the coefficient of SS of I minus 1. This should be equal to 2 plus 1, 3. So 3 into SS of I minus 1. Try to find the coefficient of I minus 2, and that should be minus 2. So minus 2 into SS of I minus 2. And let's try to find the coefficient of SS of I minus 3. So SS of I minus 3 should be minus 1. SS I minus 3, and I minus 4 should be plus 1. So SS of I minus 4. So we found this recurrence. So let's try to do a similar thing as we did here, finding a matrix so that we can find a relation raised to some power. Okay, so let's try to build a matrix for this. I guess I'm going to use tables here too. Let's let's merge here.
Oh, nice.
You don't need this actually, but yeah, that's fine. Yeah, this is the final equation we want to represent in terms of a matrix. Okay. So also let's merge this as well. Again, we will do the same thing. Represent S of I, SS I minus 1, SS I minus 2, SS I minus 3, and we will find it by difference of 1. So SS I minus 1, SS I minus 2, SS I minus 3, and this should be SS I minus 4.
If we observe the above one in the Fibonacci sequence, we took two terms, like f of I and f of n minus 1. Here we are taking 4. Can you explain why is that?
Can you repeat?
We are taking 4 terms over here and only 2 terms above.
So the basic difference is because that was a 2-degree recurrence. So it only depended on the last 2 terms, and here we can see that it depends on the last 4 terms. So to represent SSI, we need SSI minus 1, SSI minus 2, SSI minus 3, and SSI minus 4.
Yes, correct.
Okay, so so it's a 4-degree recurrence, so we will require a matrix of 4 cross 4. So let's try to find the coefficients. So we know that SSI is equal to 3 into SSI minus 1, minus 2 into SSI minus 2, minus 1 into SSI minus 3, plus 1 into SSI minus 4.
That's perfect. Correct.
And we can represent SSI minus 1 using SSI minus 1 alone. So this should be 1, 0, 0, 0. So 1 into SSI minus 1. And similar for SSI minus 2 and SSI minus 3. So 0, 0, 1, 0. So SSI minus 3, and this should be 0 into SSI minus 1, 0 into SSI minus 2, 1 into SSI minus 3, and 0 into SSI minus 4. So again, we can do a similar thing like we did in Fibonacci series. So we see that the sum, this is matrix raised to 1, and this is SSI minus 1. This sum is equal to I. Okay, so let's just copy this. So this is a multiplication. Okay. So let's write n here. This is n minus 1. This is n minus 2. This is n minus 3. So the sum should be n, and we know the value 0, 1, 2, 3. We can find the value 0, 1, 2, 3. So 1, 0. And we know that the sum is n. So this matrix should be raised to n minus 3. Correct. So this is n minus 3 multiplied by SS3210. So again, we can do a similar thing like we did here. So we'll call power, but instead now this matrix, global matrix A, should be this matrix 3 minus 2 minus 1 1. And again, yeah, like since we are calculating it modulo given number mod, so we will, whenever we multiply two matrices, we will do it modulo mod operation. So here also, since these are negative numbers, we will add mod here. So minus 2 plus mod and minus 1 plus mod in order to like do it modulo given number.
Can we write the code of that part where we are given input and we are finding these values? You can assume you have this power function.
Yeah, okay.
And you can assume you have the matrix multiplication function. in which ranked matrix.
So SS int n, int A and B, which are the initial values, right? We should use the first 4 values. This should be A plus B. Let's write here. We need the first 4 values as base cases, right? Like we need to, whenever we get a matrix, we'll multiply it by these 4 values. So A, B, A plus B, and A plus 2B, 2 into B. This should be F. And
basically this.
S, yeah, this is F. S will be A, B, A plus B, 2A plus 2B, and then 3A plus 4B. To this, we are adding 2A plus 2B by A plus 2B, so 3A plus 4B. Again, we'll find the prefix sum of S to get SS, and this should be A, 2A plus B, add 2A plus B by 2A plus 2B, so it should be 4A plus 3B, 4 into A plus 3 into B, and then we'll add 4A plus 3B by 3A plus 4B, so it should be 7A plus 7B. So let's initialize these values here. A, 2A plus B, 4 into A plus 3 into B, 7 into A plus 7 into B. Okay, so this is our matrix. B is F n minus 3 because we need to find the power n minus 3 in this case. And to get the nth number, so we need the value at the first row. So this should be like if we've got this matrix, this should be A00 into SSI minus 1 plus A01 into SSI minus 2, A00 into SS of 3, A01 into SS of 2. So let's loop from 0 to 4. So this is answer, int answer equal to 0. For int I equal to 0 to 4 actually, I plus plus, answer will be bi. So b, we will only need the like first row, so b0i into ss of 3 minus i, because we are multiplying b00 by ss of 3, b01 by ss of 2, and b03 by ss of 0, so the sum is 3, so I and 3 minus I. And again, we will do all these operations modulo mod. So okay, let's do it here. So since we are using integers, so it multiplication of two numbers which are of the order 10 raised to 9 will be of the order 10 raised to 18, which is outside the int limits. So we will write 1LL here. So it will change this number to long, and there won't be any overflow issues. This modulo mod, and again answer modulo equal mod. So we'll return mod. Answer.
Is it final from your end? Do you like to recheck it once, maybe?
Okay. Again, like we may have missed some base cases like we did previously. So let's check if n is the function is not defined for n negative, the f power function. So this is not f function, this is power function, and this is not defined for n negative. So if n is less than 3, then there is an issue with this code. So if n is less than 3, we can use the pre-stored values.
Correct.
Okay, so if n is less than equal to 3, we can include it or not, it doesn't matter because we have both here, and this will return iota. So this should be return SSN.
Very good. One thing more I would like to suggest. I mean, can you see one more mistake? Is there one small mistake?
Okay. Again, yeah, here we have to include mod as well. And so we may have to include 1LL here as well, because 10 raised to 9, like the limit of int is 2 into 10 raised to 9, something about that. So this may cause overflow here. 1LL here as well. Yeah.
One typo, I can correct this part. Okay, one question. Is it necessary to write 1LL, or can we just write 2LL? and 4LL.
Yeah, we can write that.
Perfect. So what is the time complexity and state complexity now after the final solution?
So it should be, we are multiplying two matrices in 4Q. So it should be 4Q, and we will only require log n multiplications, or 2 log n actually. So 4 cube into 2 log n. It is the order of log n approximately.
Yes.
So like if the matrix was of size k cross k, then it should be k cube log n. So in that case, this k cube term may be like more dominant in time complexity. But in our case, it is 4.
What is the space complexity?
So we are only storing matrices here. So it should be O1. But yeah, for calculating the power, we are using recursion. So we are pushing the like all the matrices on the stack. So that should be log n. Although we can write iterative power as well, function as well. So that will reduce the space complexity to O1.
But the recursive part is log n, right?
Yeah.
Okay, perfect. Very good. And we are done with our 45 minutes interview, I guess. So, few feedback. I mean, please note few things which matter in the interview really, really much. First, very positive point was that he was able to solve the complete solution. He reached the final log n time complexity. That is a really big plus point. Few small mistakes which can be improved are, I think, the formatting issues. We should have spaces between the operators and separators. Little formatting, but that's okay. Not a big deal. And I think rest everything was really, really awesome. So
someone is unable to reduce the complexity in the interview, what should be done?
Okay, what your views on this?
So like you're expected to do that. So try to explain your brute force solution first, and the interviewer always gives you help, like hints as well. So if I wasn't able to come up with matrix exponentiation, so Kirsch would have helped me like to get it to log n complexity. So he would tell me about divide and conquer, like not divide and conquer, so dividing the power into 2 and representing the recurrence into matrices. So yeah, try to explain your brute force solution. So mostly interviewers like check your thought process, and if you're near to the solution, they will guide you to the solution.
And one small tip is there, like if you are stuck and you're not able to reduce the time complexity, then try to take small examples and try to do a dry run on them, and you will see some patterns or observations that can help you. That helped me a lot. This question is optimized by previous known techniques. If anyone doesn't know, then will the candidate be passed or not? So Akshay, in my scenarios, I was able to not solve it completely, that probability question in the whole Google onsite, but the rest 3 rounds were really awesome. So out of 4 rounds, you are just based on all the 4 rounds, not just one round. So if one round is not very well or very awesome, if another 3 are really awesome, I think you can be selected.
So like they don't ask the similar questions from fixed topics, so they ask questions from diverse topics. So you're expected to know at least some of them.
Yes. How to prepare for math? So Bobby, I think you are really good in math.
I mean, again, the same thing, yeah. So like I practice on online platforms like Codeforces, and some, like I also try CodeChef long challenges. They have some good mathematics problems. And if you want to like read something maths online, I think CP Algorithms is a really good resource to study. You can find amazing blogs. And
yes, and I think Project Euler is also there for maths if you want to start.
Project, actually, I didn't try Project Euler, but I won't recommend that as well. So they don't have like mostly like number theory problems, and that requires some lemmas. Hard problems are generally not really helpful. So you can try the medium ones, but mostly the hard problems I've seen, they mostly use some lemmas which won't help much.
How many years you have prepared for ICPC? So, Bhavya, when did you start your programming? I mean, in which year?
So we had an introduction to C course in first year, but I wasn't doing like competitive programming on online judges. So I started it in like second year. I was doing it. So I started with long challenges in CodeChef, and then moved to all the various platforms like Codeforces and all. Like short, I started with long challenges, and then as my speed increased, I moved to short challenges as well. And side by side reading topics on various platforms. So I don't think there is any less, like there are a lot of learning resources. You can just Google the topic and you will probably find tons of resources. And first time I qualified for regionals was in second year. So, and yeah, so we went to second year and we didn't perform really well in the online we did well in the online qualifier round, but we didn't do good in the on-site. And then I changed my team in 4th year. So, and this year we were luckily able to get it to World Finals.
What is the difference you think between 2nd year and 4th year? I mean, obviously your experience of 2 years, but apart from that?
So like I had a different team as well. So there were different, I think, skill set as well. And yeah, exactly, experience as well. And maybe luck as well. So you have to be a bit lucky as well. Like you get problems which of topics you are strong at or something.
What programming language can you work with? Describe your experience with them. So, Bhavya, how many programming languages are you comfortable in?
So I'm comfortable with C++, and so like if you are talking about competitive programming, generally people prefer C++. Apart from that, like I'm familiar with Python for I've done some machine learning projects, and then like you can just learn it on the go. So I've learned AngularJS for internships and Java for like some project as well. So like mostly you can in software engineering you can learn it on the go, I guess, because we are using different tools and technologies every day, and in that case it's not like you will be working on a fixed technology for a long period of time. If you are talking about like competitive programming, I would say like I would prefer C++ because it has a standard template library which is like you can write your code faster, and it's also fast unlike other languages. It's probably the fastest. Like most platforms and even ICPC don't guarantee that your solution will work with other languages like Python, but in C++ it is guaranteed that it will work.
Thank you guys. Thank you, Bhavya.
Thank you for having me.
So today we are going to be having a cracking the coding interview, a mock interview session, and I've invited a very special guest for both the interviewee and the interviewer are very special to me. I'll introduce the interviewer first, Utkarsh. Hey, Utkarsh. So Utkarsh has been a great mentor and instructor at Scalar Academy. Prior to joining Scalar, he had worked with Google, and he has been into competitive programming for quite long. He is ranked 1 in top coder if I take country ranking, and he has lot of achievements in the competitive programming space. You can see the thumbnails for his glorious achievements. He'll be taking the interview. The format of this particular interview is going to be a Google style interview. The way he would have given his interview in Google, that is the kind of format. The level of difficulty is also similar to what you can expect in a Google interview. So welcome, Utkarsh, to this interview. On the other hand, we have Gautam, who is in his 2nd year and he is completing his computer science degree, pursuing computer science, and he will be the interviewee. He's been coding since since his 8th grade. He learned Java when he was in 8th standard. So he's even though he's a 2nd year student, it's almost 5 years since he started coding, and questions on trees and graph is something that he did in his 12th standard. So don't go by the number of years of experience or where he's currently at. He already has a 5 years of coding experience. So let's leave the stage for the two of them. I'll probably share the screen so that you guys can also see the problem. Over to you, Utkarsh and Gautam. So it will be a timed interview for 45 minutes, just like we have in Google as well. We might increase the timing a little bit because Utkarsh will keep on course correcting Gautam if he's going in the right direction, and we'll also give some hints. So might get stretched beyond 45 minutes, but we'll try to keep the mock interview for 45 minutes. All right, over to you, Utkarsh and Gautam.
Thank you, Mohit. So I guess the timer has started. Before we start, Gautam, can you introduce yourself first?
Okay, thank you.
Brief introduction.
So I'm Gautam Arora. I'm a 2nd year student at GL Bajaj of Institute of Technology and Management. So I have been learning Java since my 8th class, and right now I'm solving coding problems on different platforms like GFG and LeetCode. Also, I have been interested in web development, so I have been doing web development from my freshman year, and I like open source contribution. So I contribute to numerous open source projects. And also I participated in GSOC this year, but unfortunately I couldn't get selected due to limited number of seats. Yeah, so that's all from my side. Over to you.
That's amazing. Nice. So let's start with the interview directly. And this is the question. I guess everyone can see the question now. So the question is basically we are given an array and we are given two integers m and k. Now there are multiple operations which you can do. In one operation, you can select any number of elements from the array and update them like this. So basically you can add anything in the array, but once the number exceeds m, we will take modulus with respect to m. And we is any number between 0 to k. It's up to you what you want to select x, and x can have different values for different element of it. So basically, if you select two elements of it, you can keep x equal to 3 for one element and x equal to 5 for two second element if k is greater than equal to 5. The goal is to find minimum number of operations to sort the array in non-decreasing order. So basically, we have to sort the array in non-decreasing order. This is our goal in minimum number of operations. Let's take example. So first example is this is our array. Here the numbers are m is 7, k is 1. So k equal to 1 means the x value can be either 0 or 1. Now, for this particular example, the answer is 2. These are two operations which we can do. So we can either, so first operation is we will select a of 0, a of 1, a of 2, and we will select x equal to 1 for all three. So when we select a of 0 equal to, and add 1 to a of 0, it will become 5 plus 1, 6. When we add 1 to a of 1, mod with 7, it will become 0. Similarly, when we'll add 1 to 6, it will again become 7, and mod with 7 becomes 0. And 3 will remain as it is because we are not doing anything. In the second operation, we take a of 0 and a of 2 and x equal to 1 again for both. So if we add 1 to 6, it will become 6 plus 1, 7. Taking mod with 7 will become 0. Similarly, for a equal to 2, it is currently 0. We'll add 1 to it, it will become 1. So this is a non-decreasing array. Similarly, we have second example, 5, 6, 6, 1. In this case, k is equals to 2. So the values of x can be 0, 1 or 2. So in this example, we can solve it in one operation. We have selected a of 0 and added 2 to it, it will become 0. We have selected a of 1 and added 1 to it, it will become 0. And we have selected a of 2 and added 1 to it, it will become 0. So the final array will become 0, 0, 0, 3. Is the question clear to you?
Yep.
Any doubt in the question?
No, it's clear to me. Yeah.
Great. So any thoughts that come to your mind?
Okay. So we are given an array of integers a and then two integers m and k, right? So we can perform one operation in which we have to select any number of elements in the array and update according to this expression. So what we can do is we can add x to any element and then mod it with m. So x value can be less than equal to k.
Okay.
So it is varying from 0 to k. Okay. And x can have different values for different elements of a. And now we need to find the minimum number of operations to sort the array in the non-decreasing order. Okay. So let's take this example, which is 5663, and we are given value of k as 1. So now what we can do is we can take x as either 0 or 1. Now what we can do is we are adding 1 to, so m value is 7, which is the greatest value, means the value of ai can range from 0 to 6, I guess.
We can also mention that initially all the values of a of I are less than equal to. So for all a of I, it is less than m.
Okay, less than m. We need to find the minimum of two operations. So
the input also it's valid.
Let's take a look at this example first of all. So we are adding 1 to a of 0, a of 1 and a of 2. So while adding 1, 5 becomes 6, this 6 becomes 7, and when I mod with 7, it becomes again 0, and this 6 also becomes 0, and this 3 remains unchanged. And so the new updated array is 6003. And now what I'm doing is I'm doing x equal to 1. I'm adding 1 to a of 0 and a of 2. So a of 0 added by 1, I'll get 0, and a of 2, I'll get 1. Okay, so I need to sort the order. So first of all, I'll try with a nice solution. Beginning with nice solution, what I can do is, so we need to sort the array in the increasing order. So what can be the next solution? I can
It's
start with the first.
non-decreasing. Sorry, it's
Non.
non-decreasing.
Okay, so means we need to sort in the ascending order basically. Yeah. So I can start with the first element. Okay, so first basically what I can do is find the largest element in this array. So let's say the largest element is 6. So I can say that 6 will require least number of addition to become 0, if I would say like this. So 6 will only require 1 to be added so that it can become 0, and 5 will be requiring 2 to become 0. Okay, I need to find the minimum number of operations. Okay, first, can we find the maximum amount of operations required to sort this array? And minimum. So what I can think of right now is I can use binary search in a way where so basically I can find a search space for the binary search to apply on. So the search space will depend on the number of operations. So the minimum number of operations and the maximum number of operations required to sort the array. And if I'll get that range, I can apply binary search in that range to find the minimum number of operations. Okay. So what will be the maximum number of operations required? So the maximum number of operations required will be the equal to the length of the array, I guess, because so I think the concept for solving this question, though I'm not sure, is binary search on the answer. I'm not sure about that. So what binary search on the answer does is it applies binary search on the criteria. So what can be the criteria over here?
Okay, as you mentioned, if we calculate minimum number of steps and maximum number of steps to sort the array, so let's try to define them. So, can you tell minimum number of operations?
Minimum number of operations. Basically, we need to find the minimum number of operations only to sort the array. So maximum number of operations. So the maximum number of operations, I guess, would be equal to the length of the array, if I'm not wrong.
How it
Because,
is length of the array?
for example, let's start with this element and try to make it 0 by adding. Okay, I can't add more than k in it. So see, let's start with this first element. So what are the maximum amount of operations required to make it as 0? It will be 2 operations, right? Because if I'll add 1 in the beginning, I'll get 6, and then I'll add 1 again, I'll get 0. So I can get 0 here by by the minimum of 2 operations. So 2 operations for this, 1 operation. So now what I can do is, so basically all zeros is also a sorted array, right?
Correct.
What? So I can make each and every element as 0.
Yes, nice.
So let's say this. So the first array element requires 2 operations. The second element requires 1 operation. This 6 again 1, so 4 in total, and this 3 again requires.
It's not. Okay. When you mentioned 4 in total, what do you mean?
So
We are adding.
So means what I mean over here is I'm adding. I need to. So basically, all 0 is also a sorted order. So what I can do
Correct,
is
that is correct.
I can apply some operations to make each and every element 0. So that will
Correct.
give us the sorted order. So the operations required for that will be 5, means ARR of let's say M minus ARR of I. Yeah, so 7 minus 5 will give us the number of operations required to make array of I as 0. Am I right?
Yes, in case k equal to 1, then it is correct.
Yeah, it's in case the k is equal to 1.
Okay. When we're discussing about minimum number of operations and maximum number of operations, it's like we are given any input and we have to return any answer. So what is
Yeah.
the minimum answer we can return? for any given input, what is the minimum possible answer we can return?
Minimum might be 0, I guess,
Correct.
if
Yes,
array is
because if
already
we,
sorted.
yes, that is correct. So we get a minimum. What is the maximum possible answer we can return at any point of time? I mean, for any input in general.
Okay, so if the maximum number of operations required to would be, if let's say each and every element is,
0, as you mentioned.
yeah, okay, it's 0, so the minimum operations. Maximum number of operations, let me check. Let's say this element is 5. Okay, let's say if the array is in decreasing order, let's say the array is 6, 5, 4, 3. That's a
Okay.
decreasing order.
So there is
6, 5, 4.
5, 4, 3, maybe 2 or 1 also.
Yeah, 2 on 1, no problem.
Okay. And n is equals to 7. And for now, let's take a is equals to
Okay,
let's
so
do this.
maximum number of operations required would be, so let's say 6 would be requiring 1, then 2, 3, 4. So I guess n plus 1 by 2 would be the maximum number of operations, and whereas n would be the length of the array, if I'm not wrong.
Are you sure?
6, 5. Okay, let's start with any array element. So basically, if the array is, so
Okay,
let's say m.
I'll recommend you to
Yeah.
read the problem statement again. Just try this reading once again.
Okay, so given an array of integers a and two integers m and k, for all I 0 less than equal, so this is the range of the elements. Okay, in one operation you can select any number of elements from a. Oh, in one operation you can select any number of elements from a and update them like. Okay, I think I missed this, where I can, in one operation I can select any number of elements, right?
Yes, correct.
So this is
So
the
now,
expression.
yes, let's
Okay,
come back.
so maximum number of operations can be, let's say, if we can pick any number of elements in the array in one operation. So what, so let's say the array of length 6, and these are the elements. What, how would it be to pick only one element so as to increase the number of operations? In each operation I'll only select one element, that will increase my number of operations.
Yes, but
uh,
that will not be a good idea, right? And we would prefer selecting, because our goal is to minimize the number of operations. So would you
okay,
prefer selecting one element at a time, or you would prefer selecting two elements if there is option of two? So
okay,
in let's
so
take this example. Let's take only this example, and let's say we have to find the answer for this. What is the answer for this particular input?
okay, so m is 7 and k is equal to 1. So x can be varied from 0 or 0 and 1. So the x can be equal to 0 or 1, right?
Does
So
x equal to 0 make sense?
no, actually, because if I'm adding 0 to any element, there won't be any change, right?
Correct.
So that doesn't make any sense. So x, let's take x equal to 1 in each and every. So let's start with this array. In first operation, what I can do is I can add 1 to this, add 1 to 6. So 6 will become 0 because it's modulus by 1, it's modulus by m. And what I can do is I can add 1 to 5, so it will become 6. And I can also add 1 to 4 to, so that it could become 5. It's actually 5 if I'll add, and now it's 3. So now the question arises, should I add 1 to 3 or not? Let's say we add 1 to 3 as well. Okay, let's try with adding all elements, add 1 to each and every element. So what it can do, what it can become is 0, 6, 5, 4, 3 and 2. Now the array becomes 0, 6, 5, 4, 3, 2. And now what I can do is I can add 1 to element starting from ai, from index 1 to n minus 1. So the next 6 6 becomes 0. The 6 becomes 0 now, and this 5 becomes 6, this 4 becomes 5, and this similarly now I'll add 1 to starting from index 2 to n minus 1. So the operations which number of operations which I'm getting is one operation over here. Am I getting the max number of operations equal to the length of array for this case at least?
In this case, if you are doing this, then how many operations will it take?
So in first operation, I'm getting 0
0.
over here. Yeah, in second, I'll get 2 zeros. So
Third.
in n operations, I'll get n zeros, and that will make it okay.
You need 6 operations.
Yeah, for this case, we need at least 6 operations.
Okay.
Now, what will be the maximum number of operation? The question is still in my mind.
Now, let's do this. Let's remove this. And let's remove this. And let's remove this also. Now, shall we do one dry run on this?
Okay. So now the array is in descending order, as I can see. What I can do is I can add 1 to the first element. It will become 6, 3. Okay, I can add 1 to each and every element so that it can become close to m minus 1. So I'll add 6, then 4, and then 2. And now I'll again add 1 to each and every element. It will become 0, 5, and 3. Now what I can do is I can add 1 to elements starting from index 1 to n minus 1. So it will now become 0, 6, and 4. Now again we'll add 1 to each and element starting from index 1 to n minus 1, and it will become 0, 0, and 5. Now I'll add again 1 to the last element. Okay, now the array is sorted. So no, we don't need any operations.
In this case, they took how many operations? 3 or 4?
We took
4 operations.
yeah.
But it's greater than the array size.
Okay, it's greater than array of size. Yeah, it's greater.
So, you remember you mentioned that if we make every element 0, then we can get our answer. That's totally good. That's totally good observation. How many operations do we take to make this particular one 0? Or any one if we are given in the array and we have to make that one equal to 0, how many operations will it take?
Okay, so if any element is 1, we'll take, if it also depends on k, I guess. Yeah, so it depends on k. So let's say this, for this case, k is 1, we'll take m minus k. So we'll take 2, 3, 4, 5, and 6. So I think we'll need m minus k operations to make any one as 0.
M minus k?
Yeah. Let's say, oh no, minus won't work. Let's say
we have m is equals to 8. And let's say we have k equal to 2. Now, if we have a 1, how many operations will it take to make?
So one will, I'll get 3, and then I'll get 5, then I'll get 7, and now I'll add 2, I'll get again 1.
But you can add 1 and make it 0.
Yeah, so the operations required would be m divided by k.
And will it be floor or ceil of this? So it can be a boolean. Also, it can be a decimal number.
I guess it will be the floor, because it will be the floor, because let's say there's 1 over here and I'll add 2 on each iteration. 1 it goes to 3, 3 goes to 5, 5 goes to 7. Now
let's make it 3. Now let's try on this. M8K3.
Okay, so 1 will become 4 after adding 3. 4 will become 7, and now I'll add only 1 so that it could become 0. The number of operations are 1, 2, 3 operations, right?
Correct. So if we take 8 by 3 floor, it will become 2.
Okay, so that, yeah, so I think ceil will work over here.
Correct. And Can we say this is also the maximum number of operations we need?
For the one, are you saying for one?
No, for any answer. Answer can
Okay.
never exceed this particular value. Can we say this statement?
Yeah, we can say, because if it's 0, we don't need to do anything, and if it's 1, yeah, I can say that seal by m by k would be the maximum number of operations required for any element
Correct.
to
Very
be.
good. So we got our range
So
of
we got
answer.
a range
Yes, as
0.
you mentioned. Yes. Let me
So
just copy it.
now I can think of applying binary search over here, because we have got the range. Okay, so let's say the initial binary search, we can take mid as 0, low plus high divided by 2, which is initially the binary search algorithm. And I'll start with the mid and check that can the array be sorted in the operations which is equal to mid, right? So let's say
Yes.
if this is the array 5663 and the mid is, let's say, x, so now we need to check that this array can be sorted according to this expression in x number of operations. If yes, we'll go to the left hand side to find the minimum of that, and we'll store x basically. And if it's not the case, we'll move to the right hand side.
Yes. Very good. Very good. So let's write the new question now. Now the question is updated to check if we can sort the array in, let's say m mid, or what do you want to call it?
Mid will
Mids.
be fine. Yeah.
This is our now new strategy. So let's take this example and let's make k equal to 2. Now try
Okay.
and think how we can solve this question.
So a equal to 531 and m equal to 7 and k equal to 2. Now, so first of all, low will be equal to 0, and high will be equal to ceil of 7 divided by 2. Am I right? Mm,
3.
no. What I'm confused about is ceil 7 by 2 will be the. Okay, yeah. So ceil, yeah, I got it. So high will be equal to 4 for this case. Yep.
Yes, correct.
So mid will be equal to 0 plus 4 divided by 2, which is equal to 2. Now we need to check whether this array can be sorted in two operations or not. And in each operation, we can take any number of elements and try to make it as 0. Yeah. So let's say I'll start with the element 5 and start making, I'll add 2 to it so that it becomes 0.
Why do you want to make it
And
0?
what's
Why do you prefer to make this particular 5 0?
because if 5 will be 0, then I can surely say that this part of the array will be sorted, because the element can't be negative.
5 is also sorted.
But the
I
range
mean,
of elements in the array can be so from 0 to m. So if it's 0, I can surely say that the left part is currently sorted.
but the left part currently is only a single element. So no matter what element it is sorted already. So if you are standing
Okay.
at the first element of the array and you
Okay.
say that, okay, make it 0. What is the idea? Why we are preferring to make it 0? I mean, is it required? Is it not required? If required, then why it is required? That is the question.
Okay. So now the question is why we need to make the element as 0, or is there any need to make the element as 0?
Yes.
Okay, so let's say if the uh, element right now, let's say the pointer is at 5, and we check for the next element, the element immediate right element of I, and if it's less than the current element, we'll need to make it smaller than this, right?
Okay, so for every
Yeah.
element you are checking the right hand side, but we are traveling from left to right. So maybe you may prefer updating 3 instead. No? Yes. I mean,
Okay.
we are not sure we will update 3 or not because we are currently standing at the first element, and I think you are traveling from left to right. Is that right?
Okay. Yeah, I got it. Hmm. Or we
I mean,
could try with.
Your idea is correct that we can make first element 0. My question is, why is that idea we are selecting? Why we are making first element 0 and not keeping it as it is?
Okay. why are we not making the first element?
I mean, it is also possible that it may be not possible to make it 0. If the first element, let's say, is 1 and
Yeah.
we have number of operations 2, then we can make it at max 5. We cannot make it 0.
Okay. Yeah. I got it.
So the question is still the same. If we are making it 0, then why making it 0? And what will happen if we cannot make it 0? The idea is correct that making 0 is good idea, but why? That's the question.
Eventually we want that each and every element at the right hand side would be greater than the current element.
Correct.
So if let's say the current element is 5 and the next element is 3, I want this element to become, or what I can do is I can perform some operations to make this 3 greater than 5, or I can do some operation to make this 5 less than 3.
Right. Let me tell you why it is true. I mean, your idea is correct, but let me explain why. If we make it 0, then when we travel right hand side, that is, we are moving to the second element, at that point of time, we have more options. So let's say if we are not making it 0, it is 5, then when we are at this particular element, we only have option of either making it 5 or 6. So if we are able to make it 5 or 6, then we are good. If we are not able to make it 5 or 6, then we are, we say that we cannot do it. But if we are able to make this particular element 0, then for the second element, we have more options. We can make it 0, 1, 2, 3, 4, 5, and on. Now the second part is that what if we cannot make it 0? If we cannot make it 0, for example, if this is equal to, let's say, 2, the best we can do is make this 2 equal to 2 plus 2, 4, and then it's 6. And 6 will be a very high number. So making it 6 will not be a good idea, because now for the element on the right hand side, we can only make them 6. We don't have any other option. But if we let it be 2, then for the element on the right hand side, they can be either 2, 3, 4, 5, or 6. So we prefer that the element which we are currently standing at is as small as possible, which we can make, so that we have more options for the elements which are on the right hand side. Is that making sense? Oh, sorry, let me repeat. So when we are currently standing at this particular element, let's say we are traveling from left to right.
Okay.
Now, if we are standing currently at 5 and we leave this 5 as it is, then when we reach particular,
Okay.
we don't have any choice but to make it either 5 or 6. The only element which it can become is 5 and 6. Similarly, 1
Yeah.
only has a possibility of becoming 5 and 6. So elements on the right hand side, if there are more elements on the right hand side, they can never acquire any value less than 5. Either they will be 5 or they will be 6. But if we make this particular element 0, then these elements can take any value 0, 1, 2, 3, 4, 5, 6. Similarly, this also can take any value. Obviously, when we will reach 3, we will make sure that the right hand side element of that this particular 3 should be greater than left hand side. So when we will reach 1, we will make sure this particular 1 is greater than the elements on the left hand side. But if we make sure that the current element we are standing at is as small as possible, it opens up to more options on the right hand side.
Yep.
Is it making sense? So, okay. So we'll make this particular 5 as 0. That is good. So this 5 became 0. Now what we'll do?
Now what I can do is I can leave 3 as it is.
Plus 2 mod 7 is equal to 0. This is the first one. So we are leaving 3 as it is.
Yep. So now the last one, I need to make it greater than 3. So I can just add 2 to it. So it will become 3. So hence our array will be sorted.
Yes, that is correct. So we came to know that with 2 operations, we can solve this particular question.
Yeah. Now we need to go to the left hand side.
Okay.
Because we know we can solve the question.
This
Will
row will now
basically,
become.
so the high will now become 3. Sorry, the mid was 2 earlier. So now high will become 1. And mid will become 0 plus 1 by 2, which is 0, which is not possible. So now the question arises, can the array be sorted in 0 operations? So it is not possible until the array is itself sorted.
Correct, very good.
So hence we can be sure that our answer is 2. We can return the answer as 2.
Why we have not checked for 1 right now? We checked for 2, we checked for 0. Still
Oh,
low is less than equal to high. If we say that it is not possible, we will have to update low
we have to
context
move.
since
We have to move to the right hand side. So now low will become 1 and high is equal to 1 and mid will also be 1. Now we need to find whether this array can be sorted in one operation. So if we try to make it as 0, the first 5, it will become 0 in first operation, and this 3 will remain at it as it is, and again 1 can be become 3, and yeah, the array is now also sorted. So we can return, now we can easily return the answer as 1. So the minimum operations required to sort this array is 1.
because after this, if
So
we try to make this, it will become 0.
yeah, so when low has now bypassed the high, and now we'll stop our binary search. So now we say that for this particular problem, I need to make first element as 0 so that I can get maximum number of opportunities or cases to make the array sorted at the right hand side. Can I say that?
Yes.
Okay.
Okay. So the idea is more or less clear to you. Let's write the code for this particular part only, where we are checking whether we can sort the array in any number of steps. So
Okay.
the now question is check if we can sort the array in, let's say, d steps, and the input is array m and k. So you can write a function below this in which these three are parameters, and you have to return true or false. Just write the code for that part.
Okay, let me try. So let's make static boolean. Let's make is possible as the function name. It will take array as arguments int m and int k. So now we need to find whether this array can be sorted in d steps, uh, and what will be
D,
d?
D is also,
Uh,
let's say, one of the parameters.
okay, int d. Okay, so now what I'll need to make the first element as 0, right? I'll need
But
to
it
make
may
the
be possible that it cannot become 0. So you have to make sure of those cases.
okay, the edge case for this is it can't become 0. Okay, so what I can do is if it can't become 0, I'll just make it lesser than I can make means what I can do is I can make this first element as closest as 0 so
How
that
will
I
you
can
do
get
that?
uh,
I mean, if we add anything to it, it will become high, a higher value.
yeah, but I'll be doing the modulus operation each and every time by 7 also by m.
I mean, if any chance, once if we are able to reach m, we'll obviously make it 0. Why not making it 0? If we are able to make any element a of 0 equal to m by adding some numbers, then we will always prefer to make it 0, right? We will not prefer to make it anything higher than that.
Yeah, yeah.
But if we are not able to even make it 7 or even make it m by adding some numbers, then what we will do? I mean, the idea is correct that we will try to make it as small as possible. Now, if we add anything to a number, it obviously becomes a higher number,
Yep.
and we are unable to reach the modulus operation. So why not let it be what it is currently? What do you say?
Okay, so if I'll make it stay what it is, so let's say if the array, let's take for this case, let it remain as 5, and what I'll do for this is I'll add 2 in the first operation. I'll add 2 to this element, and I'll add 2 to this element, but it will not serve our case.
I mean, we first have to write the condition to check whether it is possible to make it or not. So try writing the code of that part, the checking part. How will
Okay,
you
so
check
what?
whether the we can make the current? How we can check whether we can make the first element equal to 0 or not? Just start with
Okay.
that first. Then we'll see how it goes.
So let's say k is 2 and m is 7. I'll keep on adding 2 to 5. So I can start with the loop, I guess, and let's say, and I'll keep on iterating the until the k reaches ARR of I reaches 7 or not, 6 or not, m minus 1. And if it becomes m minus 1, or if it is 5, by I can add 2 to it to make it 0. In this case, I can add 2, which will become 5. So let's say the element is 2, and I'll add 2 to it to make it 4. Then I'll add 6 to it, and then I'll add 1. So I guess any element can become 0. It is possible for any element to become 0 eventually.
What about if this is 2?
If this is 2, okay, so I'll add 2 to it to make it 4, and then I'll add 2 again to it, make it 6, and then now I'll add 1 to it to make it 0. Yeah, so I think the element will, any value can become 0 eventually.
Yes, but we have a limited number of steps. We have D steps only available to us.
Okay.
So let's say if in this particular case, let me just update this. If we have D is equals to 2. Now what we'll do?
So the basic question now is, can we make any element as 0 in D number of steps, right? So if the gap between m minus 1 and array of I is greater than
In this example, is it clear that we cannot make this to 0?
No, we can't
Yes
make
or
it
no?
in two operations.
Correct. Very good. So what is the condition you will write to check whether we can make it 0 or not? Let's skip the code part for now. Let's say we don't want code. We just want that condition. And that will be
Okay,
all.
so first we'll
So-
find the gap between the m minus 1 and 2. So the gap in this case is 4. And if the gap divided by k, so what I can say basically is, if the gap between m minus 1 and ARR of I is greater than or equal to the multiplication of k and d, I can say that it can't become 0. Am I right?
Yes. So please repeat once.
So what I was saying is, if the gap between the m minus 1 and the ARR of I is greater than k and d, multiplication of k and d, I can say that
Correct.
it can't become 0.
Yes, that is correct. So can you write it down? Just that. And we will do this.
Okay. If the gap between m minus 1 and ARR of I is greater than or equal to k into d, I can say that the value can't become 0.
Why we are writing m minus 1 minus a or I?
So ARR of I basically means the value of the array element at particular index.
If we take this example, then m is 7. So if we take 7 minus 1, it will become 6. If we do 6 minus 2, it will become 4.
4.
So 4 is equals to 2 into 2, 4. That is true.
Yeah,
But
so
we cannot
I
make
can
it.
say, yeah, so that if this condition is true, I can say that it can't become as 0, because we need the gap to be fulfilled by k into d, means we need to make the gap fulfill, right, so that it can become to 0. So it must surpass the limit of k and d.
Are you sure? 6 minus 2, 4. We cannot do it. If we write it 3, then 3 plus 2, 5 plus 2, 7. Then we
It's
can make
5.
it 0. So 3 will become 6 minus 3, 3. 3 is greater than equal to 2. No, so we can make it. And if it is 1, 6 minus 1, that is 5. Okay, this makes sense.
So this means this condition says that we can't make an element 0 if this condition is satisfied.
Because for 2 is equal, and for 3 we are able to solve it.
Yes.
This is good. So let's end the interview for now.
Thank you so much for the interview, Utkarsh and Gautam, both of you. I think the solution, we are going in the right direction. You would be able to, given more time, you would be able to think through the solution and code it out as well. So Shivam has a observation, time complexity is n into m.
We can fix last element, and then we can just try to make each preceding element smaller than equal to fixed element and fix it. Brute force to this last element this time. Observation is very correct, Shivam. So basically, in the interview, we were trying to go left to right, and I think Shivam is trying to go from right to left. So if we do this, we'll try to make the current element as high as possible, and this is a good complexity. And in turn, we can reduce it a little bit if you do little observation, Shivam. But this solution may work. That is true.
Then Vineet was when you were asking question around what would be the maximum operations. He started off with m into length of the array, and then I think Smith was correct in pointing out it will be m minus a of I by k.
Yeah, that is correct.
For a generic, like correct. So
for generic k, yes.
Yes.
In the worst case, we are making it equal to 0, so it will be that.
Correct.
The observation is correct, Vineet, but in this case, we don't need to make one less than that because we have non-decreasing array. So even if all the elements are equal, we are good.
Correct.
The current less than number on right, then make current equal to index or number in the right, whichever is greater.
I think this is the answer to the question when you're saying when should we make the leftmost element equal to 0. So
okay, so we need this time to compare with the right hand side element.
Yeah.
But if you're traveling from left to right, then it's not a good idea to compare on the right hand side element because eventually we'll update the right hand side element. If you're traveling from right to left, then this observation is correct because we will not update the right hand side element.
And I think the last statement where you were asking Gautam to write the code, what should be the condition? This is his answer, Sudhanshu's answer.
This answer is correct because we can add max k into dn of elements. That is correct.
Yeah.
So basically, till the part of binary search, that was awesome. I mean, Gautam did an awesome job of figuring out that we can solve it using binary search. Because that is now the question is easy for us to solve. Now the question only remains is to check whether we can sort this particular array in mid number of steps. If we are able to sort in mid number of steps, then we will try to decrease the value. So we'll make it L minus 1, sorry, M mid minus 1. Otherwise, we'll make it mid plus 1, the right hand side. So let me write the code for it and I'll explain. So we'll make L is equals to 0, minimum number of steps. We'll make I is equals to, I usually write ceil like this, m plus k minus 1 divided by k. This is also one of the ways of writing ceil m by k. While L is less than equal to I, now equals to L plus I by 2. I can write L plus I by 2 because L and I are not very big numbers. In case they are big numbers, we should prefer writing it like this. L plus I minus L by 2 so that we don't have any overflow while adding L and H. Then we need to check whether we can solve it in this particular steps or not. So let's take a variable last, which is taking that currently we can make our element equal to 0. 0 is a good element. Now we'll have for and we'll take a boolean variable can equal to scan is a boolean variable which tells whether we can do it or not. Right now I'm assuming we can do it. So for n is the size of the array. Now we have to check whether we can make the current element equal to 0 or not. So if the current element is a of I plus number of operations we can do is mid multiplied by k is greater than equal to what we have is m all the given in the input. Then we can do it. Otherwise we cannot do it. So if we are able to do it, what we'll do is we'll just update a of I is equal to 0 and we'll keep last equal to 0 only. So last will remain as it is because next element also will try to make it equal to 0. If we are not able to do it, then what we'll do is we'll keep a of I as it is. We'll make last is equals to a of I because the next element should be at least a of I. Now there is one more condition. If the current element is not the first element, that is if I is greater than 0, then we also have to check whether the current element can become at least what the previous element is. So we'll not write last over here, we'll write last after this. Because if we are not able to make the current element equal to the previous element or greater than the previous element, then we are unable to make or find the answer in min number of steps. So now our goal is to make this particular formula, like reuse this particular formula. So if the current element is u of I plus made into k is greater than equal to the last element, that is the previous element right now, then we are good and we don't want to change anything because, we'll just try to make it equal to a of I equal to last. Otherwise, we can say we cannot do it and can will become false and we break out of this. And once this else condition is complete, we can complete the for condition. There's a if condition. If it is true, we'll go there. Otherwise, else के अंदर ये if है, if के अंदर ये if है, else के अंदर ये statements हैं. Equal to this, and we break it. And this is the if part. This makes sense, right? Now, यहाँ पे क्या ये for loop complete. For loop complete होने के बाद we'll check if we are able to make it. Then we'll try to reuse the answer. So since we have to find minimum answer, so we'll try to make h is equals to mid minus 1. Else we'll try to make L is equals to mid plus 1. Once the while loop gets completed, we'll have to return the answer. So now the answer will be stored in the element. Say if we are unable, when we were able to make it, we are able to make it h equal to mid minus 1. So h plus 1 is the last element which will store our answer. This is what we can return as our answer. We can even have a variable answer which will store the answer equal to mid every time we hit a can. Then answer will also remain the same. But the main idea was this particular part. If we are able to make it, we'll make it 0. If we are not able to make it, we'll check, can we make it equal to the previous element? If yes, we'll make it equal to the previous element. If no, we cannot solve the question with this particular number of operations.
Shouldn't it be more than, we shouldn't try to make every element more than equal to 0, right? Because if we have a previous element for example, if you consider 1 0 0 0 or 1 6 something like that, 1 6 3. M is 7. M7 K 2.
Okay. Let's run on this.
Yeah.
Okay. L is equals to 0. H is equals to 4. M by 2. CL is 4. Then we'll have mid right now is equals to 2. So the for loop runs. We'll check if A of 0, that is 1, plus it is 2 multiplied by k is 2, is greater than equal to M is 7. But if it is okay, it will only work in case of the previous elements. Yes, we should not try every element to make it equal to 0.
It should be actually last, greater than last.
Sorry. It is last. Last, then this condition is not required. If we are able to make it equal to last, greater than equal to last, we'll make it equal to last. If we are not able to make it equal to last, then we cannot solve it. Yeah, say. This is fine.
Option says it's a bouncer. So it's not a bouncer, right? You just keep practicing such kind of questions. It is, I'd rate this somewhere in the hard difficulty, if I'm not wrong, of this particular question. It is hard, right? Right. So finding out, first of all, it's a binary search problem. That itself is hard. Gautam did a brilliant job in finding that out, that hey, we can apply binary search to solve this particular problem. So difficulty is definitely hard. So Vineet has another question, that which companies would ask questions of such kind of difficulty or in this kind of a format?
Google or Facebook, I'll say.
Yeah, so any FAANG company, right, which is primarily a DSA, who which primarily hires based on your performance on DSA rounds. You can expect such questions in those kind of companies. Any feedback that you would want to share, Gautam, with us? How was your experience?
So it was a great opportunity for me to get a live mock interview with Utkarsh sir. Thank you so much for that. And I really loved it. It showed me the path where I need to focus on more to get a job at FANG.
All right. Any things that you want to suggest, Utkarsh? Maybe what are the things that he can, go back and look at, so that he can improve upon his DSS skills? You have been a competitive programmer, right? So is that the only way to, if somebody has to crack FANG, so it should he, go and do competitive programming, or are there any better ways?
I say best is practice. That's the only way you can improve on competitive programming. For interviews, competitive programming is an advantage, but not a prerequisite. So I would recommend you to solve most of the interview questions specific to the company which you are targeting. Let's say if you are targeting Google, try to solve the questions which are asked in Google. You can find it online. I mean, we have a lot of platforms where you can find Google tagged interview questions and try to solve as many questions as possible. That's the only tip which can help. I mean, there is no shortcut to success. That what I say. Some people say that let's practice only one particular topic and hope that will come in the interview. That's not a good idea.
Solving the challenges and being regular in solving those challenges, right? Solving problems on any platform, I would say, not just interview, but right, any platform. Go there and solve the problems in a timed manner, right? Because timing in an interview is everything, right? If this was a real Google interview, you would be expected to not just answer the code, but write the complete solution as well.
30 minutes is an upper bound on the solution explanation part. If you are unable to explain it within 30 minutes, then you can assume like your interview is not going very well. But if you are able to explain the complete solution in 30 minutes, then writing the code in 15 minutes is very easy. The interviewer will not expect you to write very detailed code. If you are only able to write a small piece of code, like a sub problem, like in this example, the actual question was a binary search on answer, but the interviewer may expect you to write that part where you have to just check whether you can solve or sort the array in these steps. That code is also good enough because binary search is just 2 or 3 lines above and below.
Cool, guys. Let's wind up. Bye bye, guys. Thank you, everyone. Bye. All right, we are live. Hello, everyone. I am Mohit Yadav, and today we have with us Lokesh, who will be interviewing, mock interviewing with us. The topic for today would be a topic around system design, and I let you introduce yourself and tell me something about yourself, Lokesh.
Hi everyone. My name is Lokesh. I'm currently working as senior software engineer at Akamai. So I'm totally having 6 years of experience. So prior to Akamai, I worked at Big Basket. So currently at Akamai, I'm working as full stack developer. So I'm graduated from IIIT Newsweed in 2015. Yeah, so that's it about me.
Sure. Cool. So I'll just quickly tell the format for our viewers as well. I'll be asking questions. Lokesh will be answering me, and wherever I feel that I can, add some valuable feedback, I'll probably give that feedback to you, Lokesh, and to the wider audience as well. Right. So
Sure.
Instead of giving the feedback and keeping the feedback for the last, I'll probably keep on giving the feedback as and when we go around. Right. Cool. So I think there are a few users who have joined us. Let's wait for a couple of more minutes before we get started. Meanwhile, I'll also share the screen. So whenever you talk about, if there's a need to draw something on a whiteboard, I'll use my iPad to draw that particular thing for you. For example,
Sure.
if you say a load balancer, I'll draw a load balancer for you. If you say something
Sure.
other things, maybe application servers or databases, I'll draw those databases as well for you. Right.
Sure.
Cool. So let's get started. The question for today is: you need to design a Google search type ahead. How would you go about designing that?
Okay, so so basically, so if I look at the requirement, so basically, when users type something on UI, So he needs to get the list of suggestions. So in the drop down. So that's the basic requirement. And coming to the suggestions, so the first thing is the suggestions should be sorted by the popularity in the decreasing order. So the most popular should be at the top, or the most searched or most popular. Um, so and also sometimes, I mean, we also need to take care of the muted votes. So I mean, we don't want to show some pirated or some adult, so some kind of votes we don't want to show, so we need to filter them. So that's also one requirement. So we need to filter them.
Okay.
So I'm just thinking, so popularity and so I think for, I mean, for this, so I'm assuming we need to display top 10 popular votes, I mean popular phrases only. um,
So let's just say top 5 would do.
yeah, okay, fine, yeah,
Top
top
5.
5, yeah, top 5 votes.
Right.
And so yeah, and also the most important thing is, it should handle the typos. So if we make any typos, the user make any typos, so it should handle that. So that is one vote, I mean one requirement. Yeah, so so I'm assuming this is the scope of this system, I mean,
Okay.
as per the functional requirements. um so and
Anything
so
else that you see in a typical Google search?
mm,
For example, if you search for weather and I search for weather, we'll be shown different results.
Okay, you mean the informational results. So should we also
Right.
consider, is it like
Correct.
so? Okay, so that means, like, Prime Minister of India. So in the drop down, we'll get the answer for that. So you mean those
Not the
information?
answer. For example, if I type Prime, I watch prime time news a lot. So for me, the suggestion can be prime time. Let's suppose you search Prime Minister a lot.
Okay,
So for you, Prime Minister will come
okay,
in.
okay. Okay, got it. So using the cookies, so user cookies or personalization. So user
Correct.
personalization recommendation. Yeah. So
Right.
personalization. Yeah, that is true. That I missed it. Yeah, that's one of the thing. And so also we should we consider the location based search or
Yes, we can.
not? Yeah,
We
so we
can.
can.
So this is basically the first phase, right? Where we just
Yeah,
scope out that just by looking at Google search type ahead, these are the 5 things or 10 things that are coming to my mind.
yeah,
Now, to in order to discuss it in a 45-minute interview, it is not possible to go and design each and every
yeah,
feature. So we'll just
true,
limit the number of features that we are we are going to discuss. So I'll
true, true.
cross out popular. We definitely need to sort the result based on popularity. That's a must-have. We
Yeah,
don't have to filter words. We can assume that filtration is not required. So
okay, yeah,
this is something that we can remove.
okay,
Top 5 again. Top 5 is a primary requirement for Google search, so we need to have that. Typo handling also we can ignore. Personalization and location based suggestions are also something that we can ignore for now. Right?
okay,
We may
okay.
discuss it if we have time towards the end, the
Exactly. Yeah,
personalization bit, right?
yeah,
So let's start with these two, popularity and top 5.
yeah. So these are the functional requirements, and coming to non-functional requirements. So basically, so the system that I want. So the first of all, I mean, if I go by cap, so the system should anyway have to handle the partition tolerance because of the network failures or any failure. So the partition should be always there. So
Okay.
and then if I want to choose, that means, I mean, basically, the scalable. So I'm actually choosing scalability to be my first priority. And also So over availability and consistency. So for this case, I actually go with availability. The reason being, the reason being why I do not go with consistency is because so I mean, like eventual consistency is okay. So instead of strong consistency, eventual consistency is okay for this system. I'm thinking why, because I mean, sometimes I mean, even though if we are not, so let's say we have some top five results, but let's say I mean, we are showing let's say the incorrect one. Like in the, let's say there is a term which is top five, but we are showing top six, or I mean one, I mean, which is misplaced. So that is fine. Like it can eventually propagate, and we can show. So that's why I'm actually going with availability and the scalability. So, and coming to scale estimations. uh, I'm actually, so first of all, the number of requests. Basically, since it's a scale of Google, I'm thinking maybe some 5 billion requests per day at the scale of Google. I'm thinking.
So how did you come up with this particular number?
I mean, so basically, I just came with random, because so obviously the request will be billions. I mean, taking Google search. So that's why I came with, like, some 5 or 10 billion. So 5 billion I came up with.
Okay, a good way for scale estimation, right? This is
Okay.
I'm basically giving a feedback. A good way to do scale estimation is to look at the daily active users,
Yeah, exactly.
and then deduce what are your TPS and storage requirements would be, right?
Yeah.
So Google has I think close to 2 or 3 billion. Let's for the sake of calculation, let's assume that Google have 1 billion users, and every user maybe queries at least once a day, uses
Yeah.
Google search at least once a
Yeah.
day. So there will
Yeah.
be 1 billion queries uh, per day. These are the reads, and every read
Exactly.
is contributing to the write as well. So I'll leave
Exactly.
the thought here and let you continue the thought.
Exactly. Yeah. So this system is actually uh, read and write. I mean, so read and writes are equal here. So that means 1:1, and so that means, here it is 1. So we are so thinking. I mean, we are having that 1 billion requests per day. I mean, because we are having 1 billion users. So coming to coming to the storage. So I think we can leave this here, and then coming to storage. In our system, so we only need to store the queries. I mean, the words, or the queries. So for that, I'm thinking, so maybe, so each query at max may not store may not take more than, so maybe, like, since they're strings, and they actually, I'm thinking, maybe, like, less than a kilobyte. So that means, like, something like um, some 512 bytes or something. I'm thinking, like, half a kilobyte. So each word. So that means we are having 1 billion requests. So 1 billion into half, I mean, into 0.5 kb. So which will, I think, I need to calculate. So
This will
something,
be something in terabytes, but is that
yeah.
calculation correct? uh, because although we are getting 1 billion search queries, do you want to relook at this number? Because all of them are not unique.
Yeah, exactly. So yeah, all of them are not unique. And and in our system, we don't write them. I mean, so we don't write all of them, so we already may have other info. So that's why, I actually, so I mean, the maximum threshold. So let's say we got a word, or we got a phrase in the worst case, that is not in the system. So in that case, we have to store the whole word. So so that's why I came up with less than a kilobyte, so around maybe some 256 bytes or something. I mean 0. Yeah, so 256 bytes. So at maximum, I'm thinking.
Okay. So we'll leave the storage part here. Let's move ahead. Let's just assume that one box is not enough to handle the entire storage data.
Exactly.
Okay.
Exactly.
Let's just assume that there were some issues with the storage. The issues were that you were reducing the size of the particular record. Instead, then what I'm arguing on is that you won't be having 1 billion records to write, because let's say
Exactly.
I search for Michael and you also search for Michael, that will end up going in the same direction. I'll just upgrade the frequency. But let's
Exactly.
see the design first, and then we'll come back to the storage part later.
Yeah, sure.
Yeah.
So yeah, so I'll go with the first, go with so the basic design. So basically, when we so we can actually think of the first thing that comes to to our mind is try. So I mean, to store them in a try. So it's very very trivial and obvious that I mean, by looking at the question, so that means we have to use try. So so basically we'll have one node, and for each node we'll have we'll store them. Yeah. um so so let me first try, I mean, let me first go by I mean the flow. So basically the user sends a HTTP request, so with the votes in it. So let's say user searches with Donald.
Okay.
So as you written. So basically I mean, initially I'm assuming that I have only I mean, I don't have large scale, but small system. So basically so the client sends the request, and I actually go and look up the try. So and each lookup I actually try to find. uh, so I mean, if it's a successful match, that means if it's a successful vote, so then I actually update the frequency at the terminal node. So basically, we know that in a try, we actually store a boolean called is word to tell whether that's a word or not. So basically, yeah, so that's a word. So whenever it ends there, so so in our case, we also store the frequency. So which will be updated incrementally every time. uh, so and
So one quick
yeah,
question over here. So you said that let's suppose the search query is Dawn here, right? And there is a null character over here as well. That means Dawn is also a valid word. So you
yeah.
suggested, let's say, two words, Dawn and Donald, and he clicked on Donald. So what all, where all? Now I think each node can have its own frequency.
So
Each
each
terminal node,
node.
each node means
Yeah,
each terminal
each
node
terminal.
can have its
Yeah.
own frequency. So
Yes.
which all frequency would you modify?
Yeah. So so you're saying when user enters do and Don, so we'll suggest Don and Donald. So
Right.
if user clicks on Donald, so which we will increment, right?
Correct.
Yeah. So in this case, since user selected Donald, so that means will increment the frequency of Donald. So that means the D terminal node, because I mean
Right.
that's where that is getting hit. So this frequency will hit.
Correct.
I mean, however, there are still problems with this, but we'll eventually find it out. So this is the basic approach. Uh, so
So what are the
so we,
problems with it in terms of,
yeah,
so what I want is top
exactly.
five. How would I like, what is the complexity of your current solution basically?
Yeah, exactly. So so here the problem would be, so when I want top five, so I actually have to traverse the whole tree.
Correct.
So that means, so let's say when I said like DON, so that means from N. So I need to actually traverse through I mean whatever the depth of that a tree, I mean located at N. So I need to look them, and then I need to find the maximum of them. and then again I need to return them. So here the problem would be drilling down the tree. So I mean, we need to find, how can we resolve it.
Right. So
uh,
first of all, first question is, how would you find top five out of, let's suppose you are doing the iteration also.
yeah.
How would you actually find the top five elements?
Okay, so you mean so
We can do iterations. This is as good
yeah
as I have an array and I
yeah,
need to find top five. So
exactly. So the main thing. And also basically when I so came across this top or I mean uh, kth largest of this, so I actually think of building heap. But again, so I'm thinking, so I mean, so can we store this information in the in each node, like, so as we build the try, can we actually store, so say at n, can we actually store the information that, okay, so top five votes at n are these, can we
okay.
actually store them? I mean,
So
so yeah.
which data structure would you use to store that?
So here I'm thinking, it would be enough if we can store the references of the terminal node. So let's say, so n at n, so d is another terminal node having some good frequency.
Correct.
So here we can uh, see here we can use a heap, uh, a max heap.
Okay.
So a max heap.
Max
So
heap.
we can,
Okay.
so the top
Are
will.
you sure that you'll use a max heap for finding top five?
So because here we need top by the decreasing, I mean, by the decreasing order of the popularity, right? So
Correct.
that means every time I actually remove the maximum at the
Mm-hmm. I lost your voice, actually. Hello. Yeah,
hello.
now now you're audible.
Yeah,
Uh,
am I audible?
yes, yes, you're audible.
Hello.
Yeah, hi. Hello,
Hello.
hello. I can hear you fine.
Hello.
Hello, hello. Uh, it's a recorded session. How can you say it's live? It's not a recorded session, Sahu. It's actually live. I can hear you, man. Lokesh, hi. Hello. Can you hear me? Uh, Facing technical challenges, guys. Just bear with us for some time. Can you try reconnecting, Lokesh? I'm able to hear you fine. Meanwhile, I'll just take questions that are there. So, locations-based personalized search, yes. Fast response time, yes. Hey, Lokesh, are
Hey.
you? Am I audible now?
Yes, yeah, I think some
Yes.
glitch, I mean, yeah, fine.
No issues. We are back. So we were discussing about that. You said we'll have a max heap over here,
Yeah.
right? So do you see a problem in that? I'll give you some numbers. Let's say these are the numbers: 4, 5, 3, 0, 6, 3, 6. All right. And let's suppose you want to find top three elements. So you
Yeah.
try building a heap. So you added 4 in the heap. Then you add
Yeah.
5. So you 5 is added. Then you add 3. 3 is added. Now comes the value of 0. Should 0 be added or not? How do you decide that?
Okay.
Basically, you'll have to check
So
all the elements in the heap. to do that, right?
Wait. So okay, you're saying so we want top 3, right? So okay. So yeah, in this case, we will check. Yeah. So basically, we need to check the minimum element to find, but the minimum is not at the, yeah, maximum is at there.
Yeah,
Okay. Yeah. That's true. So if we find 3, yeah, that's true.
that's true,
So
right?
hmm.
Yeah.
So when it came 6, so we'll check with 3. If it is greater, then yeah.
Yeah. So instead of this, what we could have is a minimum heap,
Yeah.
a min heap basically. So 4 will be there, 5 will be there, then 3 will come. So 3 comes here and 4 comes here. Then
Yeah,
0,
we
0
can.
is not greater than 3, 6 is greater. So we'll remove 3 and we'll add 6. So that's how it will be done.
Yeah.
Cool. So every node will have a min heap attached to it. The size of the min heap will be 5.
Yeah.
Till that we have solved the problem. So using that, we can typically answer our query in an order one time,
Yeah.
right?
Yeah.
So
Exactly.
cool. So till that we are clear. What about what can we do after that?
Yeah. So this is the basic design.
Right.
So I mean, like I'm thinking about, what else. I mean, what other problems do we have with it? So I mean, when we scale this up, so the main problem would be the storage. So like, how do we store, try, how do we handle such a huge use scale? So basically, so one thing we can do is we can actually replicate the try. I mean, we can actually use like master slave approach by having, multiple copies of tries. And then we can propagate, like just like how in databases. So we can write to master and then schedule to slaves. So that approach we can do. I'm thinking the problem would be, so the latency would be more in this case, like
Mhm.
uh, so I mean, writing to, so there can be replication lag, so we can add to the latency of the user. I mean, the consistency can be little compromised. So this is one approach. And also one more thing is, so this is okay, like, so this is okay when we can store the try in a one machine. But what about, if we have to partition that, so that also we need to consider.
Yeah.
So what
So
if it
let's
exceeds?
break it down. What are the problems with this particular approach? Let's write down all the problems and then we'll discuss
Yeah.
one by one what can be the
Yeah.
probable solution. So what are the problems? Can you identify the problems and tell me what those are?
Yeah, the first problem is, so I would say the data partitioning.
Uh, okay. So I'd say storage,
Yeah.
right? What else?
Yeah,
That
storage.
entire data, the entire try that we are building cannot fit into one machine because we are storing the search, like we're storing the try of all the searches, right? So that is one problem. What is the other problem?
Yeah, so that is one problem. And so should I also consider on the client side, like what issues we'll have on client or not?
Not the client side. We are designing the backend, so let's focus our
Oh,
discussion
only
on
on
the.
the back. Okay. So, and also caching. So I mean, should we have to cache some queries or something? I mean, should we implement
Okay.
caching here?
So what kind of
uh,
caching are we uh, doing here? This is
uh,
a try,
I,
right? So try would be stored in memory, so we don't require a cache.
so I mean, like, so I mean, if there are some popular things, so we can actually return, I mean, we can actually store some entries in cache, and we can write it to try asynchronously, I mean, to increase latency. Because I mean, the main requirement of the system is to have less, I mean, low latency to the user. because if you, I mean, as the users are typing, it should come in milliseconds. So I mean, what if we store the I mean, like popular ones on cache, and then we update them in the asynchronously to the try.
So if you say, you, how would you identify the popular ones in that case? Is basically what you're saying is that maybe for some queries you'll save data somewhere, so that those are anyways the top 10 or top 100 or top 200 or maybe top 1000 queries. You'll store it separately, and whenever the term comes, you'll give the response from there. But let's focus on the main problem. The main problem is that we need to give a consistent
Okay.
response for every system, right? We don't have to optimizing for some queries. We can do it later, but let's
Okay.
optimize for the larger set of problems. So, apart
Okay.
from
Okay.
storage, do you see any other issue in this particular approach?
Yeah, I'm thinking. So storage and so we so I mean, so main thing we need to improve is latency. So that's the main important thing so in this system. So for improving latency, I'm just thinking, so what else we can do?
So we identified. Uh, do you think updating these top five, when we are updating the
Yeah,
frequency of a Donald,
yeah, that's true.
we
Yeah.
need to update D, L, all the nodes, right?
Exactly, I'm coming there. So so when we are updating the updating one terminal node, so
Right.
we need to traverse back I mean, so many levels to find each terminal node and so on to till root, maybe
Mhm.
to our, I mean, sometimes, and we need to update this top page. So these updations are yeah, I mean, are so here that's one problem.
So you said we need to update terminal nodes. I think we need to update every node that's there in the path till the top node. Why? Because even if a person has typed DO, there should be a heap
Yeah.
corresponding to
Yeah,
O,
that's true.
which can give
That's
you
true.
the node reference, right?
That's true. That's true. Yeah, yeah,
So
that
we'll
is true.
end up updating L, A, N, O, and right up to D. So for
Yeah.
one read, I am actually doing multiple write operations.
Hmm. Yeah, that's true. I mean,
And
so these.
while
Yeah.
I'm updating this, do you think a read can succeed?
So 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 you mean, like, so we will not so we'll not update them in sync way, but we'll do it in async way. So we'll just return the result, and we'll so use asynchronous way to update those nodes. But that still be a problem because updating those I mean, so considering the scale, the number of requests, so the updations will be a lot.
Mhm. So, basic thing, right? Let's suppose I have one database. This is a chunk of database. I have a value of x equal to, let's say, 5,
Yeah.
right? Uh, People can come and read the value of x equal to 5. There can be multiple
Yes.
read threads that can come and read this particular value. Now, let's suppose
Exactly.
there is one thread which is trying to update this value. It wants to set the value of x equal to 10.
Yeah.
Unless this value is written, all the read threads will have to wait. They cannot read this value
Yeah,
of
that's true.
x. That's true. So if I have to
Yeah.
update the value of all the nodes, till the time I will not be able to serve the reads as well.
Yeah, right. Yeah, that's true. That's true. Yeah, I mean, so in that case, yeah, Reese has to wait till these are harm. That is true. Yeah. So.
So
Hmm.
my problem is how to make this a read intensive. It's
Read.
a read equal to
Yeah.
W kind of a system. I want reads should
Yeah.
be greater than W, much greater than W. What is a way to do that?
Okay, so to optimize reads, how can we? Okay, so question is like to optimize reads. So I mean, how can we optimize reads? So I mean, when we have
Yes.
more reads,
Yes.
um,
Can I mold my system in such a way? Can I have some kind of a design trade-off added here, which will make my system more read friendly, and I will do writes only after. Like I need my writes to be very less as compared to the reads.
so how can I mean? What if we have? I mean, instead of storing a big try, so you know what if we have? I mean, because when we are writing in a big try, one made in one try. So what if we,
Mhm.
I mean, if we chunk it and store the chunks and based on the ranges, if we go to that particular try and only update that try, so that we are reducing the blast radius, right? So we are just reducing it. So
So
I'm hmm.
not sure how that would impact the number of writes. So right now, what we are doing, I'll give you a hint. Right, right now, what we are doing is whenever a person clicks on chooses one suggestion, we are updating that particular frequency over here.
Exactly.
Do you think that it makes sense to update the frequency every time a user clicks on a suggestion? By the way, guys, who are
Um.
looking for what
Okay.
the question is we are designing a search type ahead. Yeah.
Okay. Yeah. I mean, if we do not update, so then the subsequent reach will not get the top. So I mean, so uh, so when we are reading, so you're saying instead of updating, maybe we will update later, or in I mean in some intervals we'll update. Uh,
Mhm.
I mean we'll just store them and then update in regular intervals. Maybe
Yes. Yes.
saying.
How? Yes, that you're going in the right direction. Where can we store it? How can we store that?
Basically, so whenever user clicks on that, so we are actually updating. Instead of that, we'll store them in some message queues or something. So then in some message queues, and then we will actually have consumers that consumes maybe every hour or some regular intervals to update them.
So even that, when you're storing in a queue, that also has a problem, right? Some consumer will read that message and then come to update this particular try that we have, right? Instead of that, why not store it in a hash map? Can you use a hash map to store it somehow, and then after some frequency or after some threshold, you update the complete frequency?
Yeah, but so you're saying with message queues will have some redundancy, is it?
No, so for message queue, let's suppose I store it in a message queue. There
Mm-hmm.
is a Donald message here. There is a Donald
Yeah.
message here. There is a Donald message here. So I'll end up, whoever is consuming my message will end up updating the
Yeah.
queue the same number of times you have pushed the message. So my
Yeah,
rights,
that
I'm
is
not
true.
decreasing the rights.
Yeah,
Can we use,
that is true.
make
That is
use
true.
of a hash map and decrease the frequency of writes?
Yeah. So in this case, we'll have a map that will have the that will have the frequency of each word
Yes,
in that regular interval, and then yeah, we will update in one shot. So one
correct.
I mean one shot we can update. Yeah.
That's true.
That is,
So
yeah, that is,
our
yeah.
criteria could be that we only update once my frequency reaches beyond 1,000. And 1,000 for a billion, if I consider billion search
Yeah.
queries, 1,000
Yeah.
is a very, very small number, right?
Yeah.
So I
True.
can afford to have a error margin of 1,000. I don't need to,
Yeah.
it need not be a very accurate margin as well,
Yeah.
right? So just keep updating the frequency in a hash map, and once you reach, let's say 1000, you update for that particular keyword. So for Donald, you'll just iterate through the tie and update the frequencies
Yeah,
plus
exactly.
1000 to whatever it was earlier.
Yeah,
Right?
exactly.
Cool. So my one problem is solved about the right part. Now my reads are more, so I can add more parallelization. I can have I'll basically have lesser number of writes. So that
Yeah,
inherently gives me an opportunity to cache or do all sorts of optimization.
yeah.
But we still have this problem of storage. That entire
Storage.
try, I cannot push the entire try in a single box.
Yeah, yeah, that is
So
true.
how do
So
I
yeah,
get rid of this?
yeah. So like we can actually partition it in such a way that maybe I mean, I'm just iterating some possibilities, and we can actually look at the pros and cons. So one is so range based partition, like all A's or all B's at once. But this will not scale well. Why? Because let's say the votes at with starting with X or W may be less than the votes starting with other alphabet. So again, so that will be a problem. So or we can actually take prefixes and store by prefixes. uh,
Okay.
so maybe like so A to like from like AB to AD or something, so those prefixes if we store.
A to, let's say, K is something, L to M is something, and X to Z, something like this, right? Maybe
Yeah.
basically bucketing. You're basically creating the buckets.
No, I mean not like that, but still, not with length of one, but maybe three. So let's say, so there can be words like so like starting with cat. So and again, there can be many words. Maybe let's say some millions of words, and if so like taking that prefix and storing by those prefixes like so AB or ABC and so on.
So
Um,
I think AB is stored in one, and then AC is another one, AD is another one, and so on.
yeah.
Okay,
So
so let's
yeah,
suppose with this I'll have 26 into 26 characters. These many
yeah, machines. Yeah.
combinations I'll have, and it is not really necessary that I might have more machines, I might have lesser machines,
Yeah, that is
right?
also true.
So how
Yeah.
would you
Huh.
map this number with the number of machines that I have? Let's say I have
So,
n number of machines. So how would you map this? Uh, let's call this x number or x number of prefixes with the n machines that I have.
so we can actually do by hashing. So, for a word, we can have a hash function.
Mhm.
So that can actually, I mean, so when we store, so basically we'll not store all those EBs in one machine, but so basically what I'm saying, so let's say we'll determine, so words starting with prefix AB or AC, AD, and so on, some K number of prefixes will store in one machine. I mean, like that we'll store in multiple machines.
Mhm.
Uh,
So the question over there is, I think what you're hinting at is that there'll be out of these, one machine will hold multiple prefixes as well.
yeah,
But how would you decide? Let's suppose I have prefix AA. On which machine this particular prefix should go? How would you
yeah.
determine that?
So basically, so these machines will be behind a load balancer. So where my load balancer will maintain this mapping. So this with that mapping, the load balancer can relay to that particular machine.
Okay, so basically there is a load balancer which is sending it to one of the machines that is available,
Yeah,
right?
yeah,
But in the load balancer also, most of the load balancers are primarily stateless.
Stateless. Yeah.
You need to have a stateful kind of a load balancer over here. So do you
Yeah.
know how to do a load balancing in stateful system? I'm just looking for one specific term. Anand Kumar R, you are right. You use the right term. So basically, the term that I was looking at is consistent hashing, right?
Yeah. I mean, I was coming to that. I mean, as I said,
Right.
hashing there. So I
Right.
mean,
So
I'll actually eventually come, but this I got it. Got in my mind. Like, yeah. So consistent hashing we can do.
right. So we will use consistent hashing. You've still not answered what would be the shard key on what particular parameter. I think this is your shard key, right? AB and AA and EC. That is what your shard key. But what will you call that? Again, looking for a specific term. You've answered that in your previously.
Okay. So I mean, you're saying these prefixes. What do we call
Yes, prefixes.
them?
Prefixes is what I was looking at. So prefix becomes my shard key,
Yeah.
right? And once I have these prefixes ready, I can just push it to a consistent hashing ring,
Yeah.
and it will distribute the load evenly, and it will take care of how many number of servers are there, how many number of servers are not there. So we have
Yeah.
correctly solved storage problem as well.
Yeah.
Any other problems that you see?
Mm. So I mean, can you go up? So I mean, the scope is only top and I mean, I
Yeah.
forgot the scope. So only top
Top 5 and
and
popularity.
popularity. Okay. So popularity problem is solved and top is also solved.
Right.
So and we'll do optimization. So I mean, like as of now, I don't think so much problems here. So I mean,
Okay.
because the basic design is fine, like we can apply automations on these.
So we have introduced sharding. What if, let's suppose, this particular application server is holding AA, BA, CA, and some more data. What if this server goes down?
Yeah.
So how would you ensure that if this server also, if a server goes down, then also your system is done?
So I need to copy. I mean, I need to have these keys in another system. So that's
Correct.
one. I mean, right. So um,
How do we do that?
1 minute. So I forgot that. So
This is nothing but replication, right?
yeah. I mean, so
This is replication.
so that means we'll keep the replicas in other machines also, right?
Yes.
Or each one. I mean,
Yes.
each of the prefix. So, go.
Each of the prefix can be replicated to multiple servers as well,
Multiple servers. Yeah,
right?
that's what.
So
Yeah, I mean,
and that is how we can define how we are basically replicating. So I'll quickly ask you a question on consistent hashing itself, right? So let's suppose these are my server IDs 1, 2, and 3. All right.
yeah.
Now let's suppose I have one object over here.
Hmm.
Okay, this is key 1. I'll use a different color. This is key 1. Okay. Now this K1, on which server will this data will be stored for K1? Either you go in the clockwise direction or you go in
Clockwise
the
or on anti-clock? Yeah.
or anti-clockwise. So let's choose one convention. Let's go in the clockwise direction and let's store
Clockwise.
it
Yeah.
in 2.
2.
So 2 is holding my data.
Yeah.
What is the next server? If let's suppose I set the replication factor equal to 2, that means 2 server needs to hold the data.
Yeah.
what would be the next choice of server? Should I push this data to 1? Should I push this data to 4? Should I push this data to 3? 2 is the ideal candidate. I have added the data, but I need one more server to hold a copy of this particular data. Which server out of the other 3 available is the best candidate for that?
Okay. Okay. So,
Your options are 1, 4, and 3. 2 is already holding the data.
okay. So now 2 is holding. So if we assign to 3, so the problem would be, so if we assign to 3, the problem would be, since we are going in clockwise, so if 2 is also went down, for 2, we again have to store them, store the replica of 2 in some other machine. But storing in the clockwise would be a problem here, because if 2 goes down, so we will we'll have 3 for it. Wait, I'm not able to.
So you're going in the right direction. So where will this K1 be routed if 2 goes down?
So it will be routed to 3. So so in the
Right.
clockwise, it will be routed to 3.
Correct.
So that means if we store at 3, so if 3 also goes down,
Then it's a different problem.
yeah. So that's a different
We'll
problem.
solve one
But yeah,
problem at a time.
yeah,
Right
yeah. I
now,
think
if 2 goes down, there should be, we don't need to
3.
transfer the data from 2 to some other node. My newer queries will be routed to 3, and 3 already has the data,
Yeah,
right? So
yeah,
my natural choice becomes 3 in this case, right?
exactly.
Right. Cool. So yeah, I think that is we've discussed enough on this. There is one more way to decrease the number of write operations.
Uh-huh.
Can anyone, you or anyone who's joined us, tell me one approach which we can use to make this property hold true? Right now, if I don't do anything, writes and reads are same. I want a system where my reads are much greater than my number of writes. One way that we have discussed is the hashing approach. Can you guys think of one more way to do
So
this?
as you said, hash map. So similar to that, maybe map reduce kind of system thing we can use. Like we'll have a map, and then those reduced jobs will write it down to them.
What is your mapper step here?
So whatever. Okay, so in this case, so the mappers will be. So maybe if we can store the votes and map them into, into an object, like similar to hash map. So how we map them, so we can transform them into the number of occurrences, or number of the frequency, and then pass it to reducer.
Okay. And I still don't understand how. Let's suppose this is a Donald, again using the same, abusing the Donald name. But let's suppose this is a term.
Yeah.
What would be the mapper step over here? What operation am I doing here?
Yeah, so I think here this is not possible. Why? Because we'll have multiple objects. So so the map step is applied only, the transformation can only be applied on one particular object, like we cannot combine with other. I'm assuming, so that's what I
Right.
yeah. No, I think
So
that's not a good solution.
I'll take options that people are typing in the comments as well. So Jalkrit is saying, Jackrit, sorry, is saying that we can use a NoSQL DB as well. So any time you appear for a system design interview, you should refrain from saying terms like NoSQL. I'll use a NoSQL DB, and that will solve the problem for you. Why? See, Google search type had problem can be solved using Elasticsearch. right? It gives everything that I want out of the box. The aim for a system design interview is to judge whether you, if I give you a new problem, can you design it on your own? And then if you answer if your answer to a particular question is that I'll use a NoSQL DB, my question would be which DB would you use, and then I'll dissect whether you know the architecture, how that particular DB is designed or not. So unless you don't know how the architecture, how the DB is architected, do not use these terms in the interview. These are a red flag. When you know use a random technology and uh, don't know what is the architectural decisions behind that particular technology. Try to stick to the basics. If you're using caching, don't say Redis. Say I'll use a cache. Uh, and when you're saying you use a cache, it should be clear in your mind that hey, this is going to be my key. This is going to be my value, and my retrieve. This is going to be my retrieval pattern, right? That is very much essential during an interview. So keep that in mind. Yeah. Sorry. Over to you.
Yeah, I mean, so yeah, I cannot think of it.
Anyone who's done machine learning, they would,
Okay.
I think, be able to uh, get a better hang of it. It's a simple statistical tool, typically used in uh, not just machine learning. Machine learning is one area, but it's a purely statistical way of doing things.
So
So
someone said
Arpit says
Bayesian. Okay.
Bayesian. Okay, Bayesian, not really. Uh, but what you can typically do is use sampling.
Okay.
The idea of sampling is that if it is popular, no, don't use average or anything like that. Just use sampling. If it is popular, right, there most of the chances, if you just skip 99 requests and choose the 100th request, it will be the request of the most popular one. For example, if it's a India versus New Zealand final that is going on right now, if I search for IND and missed out, just randomly choose the 100th request, it will be for India versus New Zealand. And because I have that kind of scale, I can just remove or let go of the 99% of my request and just choose one request that is coming to me. Of course, there will be some error threshold over here. It will not be accurate, but it will be a very much close to accurate guess, I would say. So sampling is one more thing that you can typically do. I'll only consider the 99th or maybe the 100th request. 99 request, I'll just I won't just care about it. And in fact, this sampling way is used in many applications, right? What I was saying is, so I'll just summarize what I just said, right? What I just said was that if something is very popular, like for example, if I type IND, IA will automatically be suggested because India has been searched by many people, right? If it is, if there is something else that is coming out of IND as a prefix, it will be searched by many other people as well. And by the law of averages or by the law of randomness, what I can surely say is that even if I remove the 99 first 99 requests, whatever is the 100th request, that will the probability of getting that particular number which is popular, that is really high for a actually popular request. I'll give you a small example. I'll write a let's suppose I have 4 spaces, 1, 2, 3, and 4. All right. What is the probability of picking 1? it's 1 by 4, 25, and so is the case with every other number that is there in the array. Now let's make some more interesting. Now what I've done is I've added one more one. Now if I ask you to pick a number randomly, there are 50% chances that I'll end up choosing one. Now let's remove one, add one more one in the 4 numbers. The percentage now shoots to 75% chances of getting one, right? And this is the law of popularity. Out of the 4 numbers that I had, one is really popular because it is occurring 3 times. If I choose a number randomly out of this particular batch, I have 75% chances that I'll get one. For truly popular systems, the occurrence of this one is over 99%, right? And that is what I was hinting at. You just sample your request, create a sample of, let's say, 100 batch. Out of that batch, pick one element randomly, and the chances are that you will end up picking up the most frequent or most frequently searched phrase. So this is a small idea about sampling that you can go back and apply in other systems as well. Yeah, I hope this leaves you with a food for thought. Yeah, cool. Anything else that you want to add, Lokesh, on the problem that we have discussed?
So on backend, yeah, I think that's it. So, so I mean, just one thing is that maybe on clients we need to add throttling. That so like as we are typing, so like we said debouncing. So this term called debouncing. So I mean that means, let's say if I type a and there's an interval like like some 600 milliseconds like that. So if I stop typing, then I should send a request. If I'm not stop typing, so I should not send the request. So that debouncing maybe we'll add on clients. So
Right.
to optimize, yeah, I think that's it from my side.
I think your voice is cracking. I don't know if that's just me or is
So
it cracking?
is it
Sorry.
so is it fine
It's
now?
better now.
Is it fine?
Yes,
I
yes,
mean some
yes,
maybe.
yes, that's better.
Yeah.
All right. Cool. So we've discussed a problem, a system design problem with everyone, right? And I think we are quite done with the 1 hour mark that are typically, added, given for a system design interview as well. I'll give you, before leaving, I'll give you guys a thought about what are the typical challenges that people face during system design interviews, right? Pacing yourself is quite important, right? I think the pace that you showed, Lokesh, was spot on. We were able to cover quite a lot of ground in 45 minutes. We didn't touch upon many factors as well. I didn't go deep into understanding the how would you implement a try and all that. But I think that is not an objective of a objective as well, right? We didn't go into things like rate limiting and things like how would you actually persist a try on DB, right? Everything
Yeah.
was there in memory, so we didn't go into how would you persist a particular try, so that
Yeah.
in case the server restarts, how would you handle that? We've not discussed so we've not discussed the length of a particular prefix that you will add. So would you add a also as a prefix into the consistent hashing ring, or would you require a minimum length? If you're having a
Yeah.
minimum, like what are the pros and cons of all those things? That is something that we've not discussed. But I think within a given the time frame, this is a decent enough discussion. There are multiple other aspects as well that we can look at. For example, personalization. Typically, if you are interviewing for a senior role, you would be asked to go into one peripheral area. I didn't get a time to dig deeper into the other peripheral features that we had missed out. The other peripheral features are primarily there to test whether your approach or the solution that you're giving is extensible or not. Right. For example, if on this particular system also you want to add personalization, how would you change or tweak your
Yeah.
system? Do you
Yeah.
require to change the entire logic? If that is the case, then your system is not extensible. And extensibility is a major component when it comes to testing out things, right? So I'll probably jump to questions that are there in the comments, right? If you have other prior engagements, I think I had blocked only 1 hour of your time, Lokesh. If you have any prior other engagements, feel free to drop off. I'll take the questions and then I'll wind up. Do you want to stay or
Sure.
do
Sure.
you want
So I want to drop off because my mom is waiting for dinner. So yeah,
Sure,
I'll
sure.
drop off, guys.
All right. Thank you so
Okay,
much
guys.
for your time,
Thanks.
Lokesh. Have a nice day. Bye bye.
Yeah. Thanks. Yeah. Bye, guys. Thanks.
All right, guys. So I'll take up all the questions that might be there in this particular chat window. Uh, if you've still not typed your question, please do so. If you want me to interview you on do a mock interview for you as well, please mail us your resume at youtube@scalar.com. I'll just type it down so that it's uh, visible for everyone. This is the ID that you should typically be looking at. All right. Let's now go to the questions. Bhagya says fast response. Okay, these are the answers. Where are they in question? Should we handle location, current issues, and frequency, at least in count? What's the profile of the interviewee? I think Jay Kirat, we told like in the beginning we started off with the profile of the candidate. He was having 6 years of experience, an SD2 at Akamai, and prior to this he was working with Book My Show. I hope this answers your question. So Jayant has a question. In yesterday's short URL, why we use user ID for the table if you're searching for shortcode in the whole DB and providing the actual URL won't be time consuming. How about using a key value pair? One that was so the schema that I wrote that was primarily for a system with a very less amount of uh, which is basically designed for very less users, not for a massive scale. A KV, a minimalistic KV is the one that will work the best for a URL shortener kind of a design. So try can be partitioned based on location. That is not a good approach, I would say, Arpit. The reason being because if you break down the try on a location basis, that will be adding personalization. But what we were designing today was basically a search type head that is globally accessed, and the frequencies were also changing globally. The prefix approach that we discussed at the end is basically the correct approach. Arpit says you should not block reads. How does it matter if the value goes a little here and there? Exactly. I think what he's referring to is that when we are writing a particular system, that is when we should never, whenever we update a particular frequency of a particular record, that is when we have to basically block all the reads because the write will take a lock on the particular record, and hence reads will not happen. So we should avoid it at all cost. We have discussed two approaches to avoid that. One is hashing and the other one is sampling. So we can use either of the two approaches to uh, basically block down the reads and write value. So I see there are many people who have told that caching is the best way to do this particular thing. However, I would like to differ from them. Caching for a search type ahead is not a very good idea, right? We are actually caching quite a lot of things in the node, where we just traverse to the node and we're finding the output. We need to understand that caching by itself is not a solution to reduce the latency. For example, if I maintain a hash map in memory, that is much more faster as compared to storing the data in Redis. So whenever you are appearing for interviews and giving your answers that I'll use caching, have instead of using caching word, or instead of using this, tell them where are you going to cache it. Are you going to have a distributed cache? Are you going to cache it on the client side? Or are you going to use maybe uh, or maybe at a load balancer, or maybe at a global cache or a DB cache? Specify what kind of caching you are going to do and what is going to be the key. Here in this case, I am not sure what can be the typical key of key for a particular cache. How many prefixes can you typically cache also, and the frequency also. What if, let's suppose I cache, I'm taking the same example, Donald. If I cache Don and save the top 5 words, how would you update the top 5 frequency? That will become a problem, right? So I hope everyone who is actually attending the session understand that caching here is not the best way to go ahead. So Vishnu says NoSQL is a good option. I think I have spent some time describing that. Don't directly jump to a NoSQL database. Identify what are the requirements that you would need to design such kind of a system, and then discuss the trade-offs. Directly jumping to a NoSQL is a red flag, especially if you are interviewing for a higher up profile. For SD2, it will still be okay. But for SD3, it is a definite red flag. Is it's memory already in memory? What will you cache? What does it mean exactly, Arpit? That is what I was hinting at. What would be the criteria for caching? I think Arpit, I've answered that. We will shard based on the prefixes. Okay. So Vineet is asking what we need to be prepared before giving an interview with you. In this particular mock interview, I had basically told Lokesh that, hey, I'll be asking you to design a Google search type ad. So the question was given to him already before he came for a mock interview. So whenever I take an mock interview with you, I'll probably give you a heads up that I'll be asking these questions. The sole purpose of giving the topic beforehand is we want to have a meaningful discussion while on a mock session. In an actual interview, of course, you will not be knowing the topic, so it's important to understand the system design concepts and prepare based on that. So typically, if you want to do a mock interview with me, I can give you a topic and we can have a mock interview on that, right? Any such stream for low level design? So this system design interview is a superset of the low level design, right? It's based on two important parallels. One is the low level design. For a system design interview, you need to design the schema. Schema designing comes under a part of low level design. I, as an interviewer, might ask you to write some classes and code for that particular business logic that I'm asking you to implement. If you are a more experienced candidate, I might spend more time in discussing about the systems. Right. If you have lesser experience, I might ask you to design the classes. For example, the same question: how would you go about designing chess? uh, I would ask this question differently to a person who's has maybe a college fresher, or maybe have 2 years experience, and maybe with a person of 10 years experience. For a person with a 10 years of experience, I will drill deep into how would ensure make this particular chess game into a multiplayer game, or maybe not a multiplayer game, basically a two-player game, two-player online game. How would he bake in artificial intelligence? How would he make sure that there is no there's no cheating component that is happening in the chess tournament? So, uh, doing uh, focusing more on the system design aspects of it for a 10 years experience. For a lesser experience, I'll probably spend time in how would you design the queen class, how would you design the pawn class, how would one extend to the other, and how would you abstract out the common functionalities. That is what I'll test probably for a with a 2 year experience candidate. I've learned from. Thank you so much. I hope I take it as a compliment. Uh, in memory, hash map is not scalable, can be used by a distributed server. So you can have a Redis cache as well, in case you want to have, in case you are limited by the number of, or limited by the memory that your application servers are having. You can typically take this component out in a different system itself, right? So that would not be a problem. Is it possible to explain try implementation at DB level in your upcoming YouTube masterclass? Unfortunately, YouTube masterclass will not use any concept of try. What we can, however, do is there are people like we also take masterclasses on data structures. We can pick this topic up in one of the data structure masterclasses, not at a system design masterclass, right? And DBs, as far as I know, there are no DBs which will allow you to persist or try. Uh, right? You have to store it as an object and retrieve that as an object. For R much greater than W, keep cache on servers and have some hybrid approach for write through and write back policies to update the data back. Yes, Pratik, we can do that, but understand that tries are also stored in memory. So by having a separate cache layer, you are not actually gaining anything out of it. The amount of time you will spend on reading from a try will be closely similar to what you will to the performance that you'll get out of the cache as well, because essentially both of the systems are reading data from memory to find out the top key elements for a particular prefix. The max you have to go for is maybe 3 or 4 characters, or maybe 5 characters max, and you'll get the complete string. So you are actually not going traversing a lot of data when it comes to having the reading it from the try. Redis is a event driven system and not necessarily slow need. Okay, he's answering to Anand. What is the question of Anand? Okay, Redis is single threaded in nature. It can slow down the entire system. So Redis, even though it is a single threaded, it can serve the kind of latencies that you can get out of Redis server is around 1 to 2 or maybe sub 5 millisecond kind of latencies. So in 1 second, you can typically serve from a single thread itself. You can serve around 500, 200 seconds, and then there will be thread multiplexing can also happen. So sorry, you can have a multi-threaded application interacting with this particular thread. So that also will give your system a huge boost. So using context switching and all that, I have had instances where I can, with a single Redis server, I can serve million QPS. So Redis is blazingly fast, even though it is a single threaded application. Redis is an event-driven system and not necessarily slow Node.js, but very fast. CPU intensive. So Arpit says Redis is event-driven system and not necessarily slow. Is drawing parallelism from a Node.js server. CPU intensive application do require multiple threaded system, but not with just a network IO intensive. Agreed on this. Most of the time is spent on IO thread. So exactly. So thread not thread contention. I forgot the term for that. Yeah, context switching. So context switching will there'll be multiple threads which will be reading the data, and using threads will switch the context to give chances to other thread which is waiting for the waiting to be get into running state. Sharding, please. I think Bhavan, what you're asking is, are you asking me to explain what sharding means? I'll be uploading one video on sharding on under the system design series. So please stay tuned. Right. So if you're interested in knowing any other system design concept or topic, please feel free to comment on this video. I'll end this video now. But tomorrow, I'm going to tell you about how to answer the coding experiences. Like how do I answer coding questions, DSA questions in an interview. I'll probably invite one more speaker who will tell. So. I'll basically invite one more speaker who is also done taken multiple coding interviews, have himself cleared multiple company coding interviews at multiple different companies, at farm companies as well. So tomorrow will primarily be focused upon how do you appear for and how do you think about a approach when you're going for these coding interviews. And day after tomorrow, I'll take one mock coding interview, similar to in a similar format that we have done today, right? So I'll see you guys tomorrow. I'll leave leave the class now. Hopefully that made sense for you. Please subscribe if you have not subscribed to our channel. Right? I'll see you guys tomorrow. Bye bye.